I'm from University Miguel Hernandez. And we have 1 hour and a half, and we have 6 presentations, so it's going to be 15 minutes per presenter. I hope, as we would like to give a couple of minutes for any question, I would thank you if you could do the presentation in 13 minutes or so. I will tell you when it is 13 minutes, so you should be finishing, okay? Anyway, if you are close to 15 minutes, I will stop you. So please get in time, because we are in a schedule. Okay, so we are going to start with Professor Panagiotis Frangos with the presentation See State Characterization Using Experimental One-Dimensional Radar Signatures and Fractal Techniques from Georgios Ouraimis, Apostolos Katopoulis, Basil Masinas, and Panagiotis Frangos, who is going to be presenting. So Panagiotis, when you want, you
yes,
can...
Thank you very much. Thank you very much, Roberto. Thank you. I'm putting the share screen. Yes. One second. Yes. Yeah.
Mm-hmm.
Just 1 second to put it full screen, Alberto. Yeah. Alberto, can you see it? Okay, full screen.
Yes.
Okay.
Everything.
Thank you very much.
When you want.
Thank you very much. Yeah. So good morning, dear colleagues. Good morning to everybody, and have a fruitful conference. I have about, as Albert, about 13 minutes to briefly describe you a piece of research work that we're doing at our School of Electrical and Computer Engineering at the National Technical University of Athens, Greece, along with George Ouraimis, who is a postdoc in our laboratory, and Apostolos Katopoulis and Basil Masinas, who are PhD students in our laboratory, which is radar and applied electromagnetism laboratory. So the title of this piece of work that I'm going to briefly describe to you is See State Characterization using experimental one-dimensional radar signature and fractal techniques. We have the Norwegian Research Institute FFI at Oslo had the kindness to provide us some real experimental data from radar data from helicopter. Actually, it was a PICOSAR, small synthetic aperture radar on helicopter, and this was and this was an experimental study of sea clutter, of sea state in sea clutter, which took place, as you can see, in 2014 in south of Italy, Taranto, sea of south of Italy, in September 2014. So the experiment took place in this particular experiment of sea clutter analysis. It took place in 2 subsequent days, 23 of September 2014 and 24, as you can see, 24 of September 2014. In the first day, the sea was in the first day the sea was turbulent. And then the second sea, the weather changed very rapidly, and we had calm sea. So it was appropriately chosen so that we have the turbulent sea in the first day and the calm sea in the second day. And here I will show on the left some particular specifications of radar collections, but I don't have the time to go in technical details regarding, for example, the beam width of the antenna. And the experiment was about 5 minutes or 10 minutes each day. I'm sorry. I'm sorry. Each day, and the grazing angle was in both days was about, as you can see on the left, from about 4 degrees to 54 degrees grazing angle. When I talk about grazing angle, is the angle between the horizontal sea surface and the direction of propagation of the electromagnetic waves. This is called in the radar technology the grazing angle between the direction of propagation of the radar waves and the horizontal sea surface. The FFI Institute was so kind enough to provide us this data during a NATO collaborative working group, which still continues. And we still continue to analyze this data. So, for example, in this transparency, I show to you on the left examples of radar range profiles. Once again, this is a picosar, small synthetic aperture radar, and on the left you see range profiles as a function of time. So this is the signal as a function of time. For example, on the bottom and the left, you can see a calm sea, representative calm sea range profile, and above it, a turbulent sea range profile as representatives. And you can see this is for angles for grazing angle equals to 20 degrees, for example. So, by the way, very shortly, this paper is 1D. Let's say we're making 1D mathematical analysis, range profiles with the signal, the return signal as a function of time. And now our research already moved to, let's say, 2D or 3D in case. So we're looking all the data because in the SAR, you collect a set of data, a set, of course, of range profiles, say 5,000 range profiles in this experiment. As the helicopter moves up, I forgot to mention that the helicopter moves downstairs. So we observe the sea for different grazing angles. So now we progress these ideas, and we observed in all these hills 3D functions, f of x and y, which are the raw data of the radar. And we're looking now at this direction of research. So, but this is still in this presentation we will see one-dimensional functions, range profile, signal as a function of time on the left, and on the right is the fast Fourier transform of this, which is the power spectrum S of f. Okay, the signal as a function of frequency, turbulent sea and calm sea. Okay, now I'm not going to go into details of the analyzing of this signal. We had some difficulties because the data were not provided by us. So we had to guess what it's about and to be in touch with the Norwegians to ask some questions. What is about? What is the full information about this data? But okay, I'm not going to analyze this too much. Also, we have had a simulation tool which was produced by our group about 4 or 5 years ago, and we're now also in the process to compare these results with a simulation tool produced by ourselves. In any case, I continue with my presentation. Here we applied some criteria to establish the sea state characterization. For example, we are using fractal mathematics, and to calculate the following quantities: the fractal length of the range profile and the fractal dimension of the range profile. This is well-known techniques in mathematics to calculate the length and the fractal dimension of an anomalous curve. So on the left, okay, I'll explain. By the way, take into consideration that here we're using normalized range profiles from 0 to 1. So we normalize the range profiles obtained by picosar from 0 to 1. So this is a challenging problem because in this case there is no information about the signal strength. So this is most if we can characterize the sea state from normalized range profiles, this is even better from practical point of view. On the left, you can see particular range profiles, and also you see up and below it something called the upper blanket or the lower blanket, or the upper curve or in the lower curve. Blanket is used in 3D. Here is the curve, the upper blanket or the lower curve. This is one of the methods to calculate the fractal length of the anomalous curve, which is calculated as the ratio of the area between the upper curve and the lower curve divided by the height of it, 2 delta, which is the height of it. So let me proceed. This is done for several iterations, delta or epsilon. I'm not going to go into these details. This is one standard method to calculate fractal length, the fractal dimension. For example, here we show a simulation, a simulated curve, and to show the accuracy of our algorithm. So here you have a simulated curve, as you can see, the upper blanket of it, the upper curve of it, and the lower curve of it. And without going to details on this difficult mathematics, you can see on the equation the upper curve and the lower curve selected in a particular way in the paper by Peleg for fractal analysis. And the delta or epsilon is the iteration, or in the iteration. And on the right, you can see the fractal length as a function of iteration. Let's say the derivative, let's say, of this curve of the fractal length is the fractal dimension as a function of iteration. And this is a characteristic curve for characterizing the surface or the line in fractal analysis. Okay, so here are the equations. Oh, my time is very limited. So here are the mathematics of it. You can see, as I told you, the area of the strip between upper and lower curve, the area, and if we divide this actually by 2 delta, as shown in the second equation, in a variant of this equation, we calculate the length, the fractal length, as a ratio of the fractal strip, of the area of the strip, divided by the height of this strip. L of epsilon is the fractal length as a function of iteration, and the fractal dimension is calculated after that from the fractal length. So unfortunately, don't have the time to analyze this in detail. So let me try to conclude. Here we have some results, and fractal dimension is a function of iteration. This is called a characteristic. I'm sorry. This is a characteristic curve. Sorry. And the interesting thing is for all angle of incidence. For example, this is shown for 10 degrees angle of incidence and grazing angle in the 25 degrees. 25 degrees grazing angle, and in all cases, the fractal dimension of the turbulent sea had the higher fractal dimension. So we, in all cases, for all data that we analyzed, and we calculated the ratio of this, which is called the sea state index, as we can see in the table, for different grazing angles, and we can see continuously SSI index larger than 1. The same happens for fractal length, as you can see. Only for the first iterations we have, but in all the other cases, the fractal length of the turbulent sea is higher, and the sea safety index and so on. In addition to that, because my limit is very strict, my time is very limited, we have the variance of these curves, and we had similarly very promising results for the variance of the range profiles. Finally, as a fourth criterion, we used a criterion usually used in C clutter analysis in the literature. So here we have the power spectrum density, return power as a function of frequency. And for lower frequencies, you can see that actually the least square curve, which is the dotted line for turbulent C, which is the dotted line, is always higher than the slope of the least square approximation, which corresponds to the calm C. So concluding and finally make the final remarks on it, we have a summary of how to present it. And now is very important is our plan of our current and near future research, which is regarding the 2D analysis that I presented here. We have comparison between the experimental data, experimental results, and simulated results that we have already developed 4 years ago, an electromagnetic tool for this. And also, as I told you already, we are already doing 3D analysis on the full data, full set of range profiles, which might have some advantages and disadvantages, also by using advanced mathematical techniques. Also, we're looking at the spectra, because also the spectra of these range profiles, because already the Norwegians made some preliminary analysis and showed that for calm C, and I'm finishing with that, the calm C, the spectra appear to be more uniform in their report. Okay, and also perhaps this can in the future can be done for also terrain characterization. Okay, so I have some references here. For example, Mandelbrot for fractals. Some old works of our, with Dr. Malamu and Kotopoulos and Pouraimis for fractal analysis and so on. And also number 6 is my professor advisor at the University of Pennsylvania, which was expert in fractal mathematics, fractal electrodynamics, and papers for document analysis by using fractal techniques. And many, Perizzi is a very good Italian professor in also in radar and fractal analysis and other. Yes, I'm sorry. Yes. So finishing, we're still working. Thank you, Alberto. We were still working on this. It is not finished. We are already progressing on this, and we hope that we have better and better results on this difficult problem of C clutter analysis. So, Alberto, that's it. So, if you have any questions, please feel free.
Thank you very much. Just in time. Thank you very much.
Thank you so much. Thank you so much. Thank you so much.
Thank you very much. Very interesting, as always, Panos. We will have time for a very fast question, if any. Okay, no?
I have a question.
Yes. Yes.
Okay. Once I have been doing this how things, and we use this box counting dimensions calculations. Is it any relationship with your method?
Once again, here in this presentation, we used the experimental radar data provided to us by FFI in Oslo, and we used a particular fractal dimension method, which we called MFS or blanket method. MFS means modified fractal signature method. So in this stage, we establish we try to establish a clear distinguishing between turbulent C and calm C, and we're in progress to compare these results with simulated data which are produced by our own electromagnetic code. So up to now, there is still not a clear comparison with other methods, but we are doing this now, currently, comparing this criteria with simulated data obtained by our and using our own code, a computer code for this problem.
Okay.
Thank you.
Thank you very much. I think this is it. Panayotis, thank you very much for your presentation.
Thanks so much.
We are going to move to the next one. Next one is titled is Development of Georeference 3D Point Cloud of GPS denied environments using backpack laser scanning system. with Dr. Sayer Riaz as the presenter. So, Doctor, thank you very much for coming, and your time is starting now. You have 13 to 14 minutes and then one fast question, okay?
Thank you so much, Dr. Alberto.
Thank you.
Okay, so my presentation is visible to you?
Yeah.
Okay, thank you. So this is actually, good morning, everyone. This is actually a funded project to develop 3D models of the indoor environment where GPS signals are not available. And I'm thankful for my co-authors and co-researchers who worked with me to finish this task. So technically, what is the nature of this work? We are using 2D laser scanners. We are joining them in different orientation. And then we are making maps of indoor places, indoor areas. And then we are converting those information into georeference signals, means we are converting those information into lat-long information. So why we are choosing our 2D laser scanners? Because actually they are available from different companies. They are now they are giving very nice features of the environment, and they are having a lot of different ranges available. So this is for just explaining that how they are working. This is the slide which you are watching here, that they are actually taking a slice of the information of their surrounding, and if there is some obstacle available, so they can inform you that there are some specific walls, specific objects present in their vicinity. So if, for example, I'm holding this sensor and I'm moving in some room, some indoor place, and I'm just taking scans on different locations, so you can see that I can just accumulate all the scans and I can make some 2D map, just like here you can see from the blue line. And then this is the information of that floor where I'm moving. Now, if I'm needing some map for 3D information, so I need another sensor. So in this work, we have combined more than one scanners. As you can see that this is the horizontal one, which is responsible to calculate 2D map. And then we are connecting one orthogonal sensor here, and it is now detecting the Z axis of the area. So now technically we are now having all three axis information, X, Y, and Z. And then we can combine this information to construct the map of this area. So this is one example which I have just placed here, that we have taken this experiment in some indoor place, and then this is the constructed 3D point cloud of that area, and you can see that we are having X, Y, and Z information generating from this method. There are different kinds of platforms available. For example, there are some handheld system on the left-hand side. You can see there are some trolley-based systems or some backpack systems. So in this work, we have chosen backpack system because this is comparatively easy to hold. And you can see that we have now 3 scanners on different orthogonal orientation, and we are having this physical implementation of this particular mechanical design. And then the surveyor is just holding that backpack and moving in that area where you need to make map of that environment. Technically, there are, if you see, there are some local references available for every sensor. So we are converting all local sensors data into the main horizontal scanner data. And when the person is moving, so actually we are combining all that data with respect to this horizontal scanner. This is the instrumentation block diagram for all the system. So we can divide in 2 steps. First is that when the person is carrying the backpack and doing surveying of some area, so we are calling that thing that this is the online step, as you can see here. So during this step, we are collecting all the scanners data, and we are using ROS based information collection system, and all the data has been taken in a ROS laptop. And then we are, during this process, we are running a library, which is a Hector SLAM library, to compute the pose of that surveyor and the 2D map of that area. Then we are just collecting this information and storing during this surveying operation. And then we are switching to our offline step. And during that offline step, we have used MATLAB scripts to make first registration of all the scan which we have collected from different scanners. And then we are registering this information on our global frame. And then we extract the building planes. For example, if you would like to extract building information of walls, pillars, and some other objects present. And finally, we are going to transfer this information into georeference coordinate system. So technically, I'm just summarizing the mathematical steps. So the Hector SLAM is running on the ROS node, which is running the probabilistic computation for estimating the map and 2D pose of the surveyor. And then when we are having this information, we are just transforming the other two scanners information on the local reference of our horizontal scanner, which is indicating by the equation number 2. Now, by combining all the scans which are now available from all scanners, we are now having a single complete scan of the environment. And then we are converting that scan into world reference based on the pose estimation which we have received. So this is one example when we would like to make the indoor map of some environment. So for example, this is the corridor of my campus, and you can see that I'm holding this backpack system and I'm moving in this corridor. And by moving in this corridor, on the right hand side, you can see that this is the developed 2D pose, which is indicating by the red points. And on the with the sign color, you can see that this is the 2D floor plan of that corridor. And after registering all the scan data during this process, you can watch that now I'm having 3D model of this corridor. And important thing, if you can see that all the information which is available, for example, vegetation information, for example, pillar information, from, for example, some civil structure information, we can gather from this 3D model of this environment. And because we are using 30-meter Hokuyu scanner, so that's why you can see that we are having on the left-hand side and right-hand side, we are having approximately 25-meter information. So if you are having some more greater range scanners available, so you can construct with more detailed information in greater ranges. And after that, as I'm telling to you that when we have constructed this this 3 XYZ information, which is right now in meters. So now we need to convert this information into lat-long information. And as you can see that this place is not having GPS signal. So we are now needing some conversion of this meter information towards the lat-long information. So we have done a very simple step that we have find out some closest area where we can find the reference GPS locations where we are getting some GPS signals. So you can see from A and B, we are getting some values of GPS signal available. This is actually the campus road. And then we are taking midpoint of that campus road and just making one orthogonal projection of that area towards the area where we have moved. So you can see that this is the red area where we have moved, and here we are not finding the GPS updates available. So after that, we are having some small trigonometric operations. We just convert using some trigonometric operation. We have computed dy and dx, and we converted that lat-long information into the meter information. And as you are watching that, this area is not so much long, so we are just using some specific conversion. We are not designing a proper equation which is complete, which is a little bit more complex to convert meter information into lat-long information. So after that, if you see that same area is now converted into lat-long operation, and you can see that now we can represent this indoor place with respect to lat-long operation. And actually this is the task which is given to us by different local companies, because they would like to actually model buildings having multiple floors, and they are having multiple offices. So they would like to target them with respect to lat-long operations. So that's why we did this job, and we just delivered this unit to them. And there are some more results. For example, we have taken another corridor, and you can see that this corridor is comparatively more longer than the previous one. And this is the 2D map which we have constructed. And after that, this is the 3D model in terms of lat-long operation. And you can see again that there are a lot of information available with respect to vegetation, with respect to civil structures and some other minute information. And then we have visited one construction site. You can see that on left-hand side picture that there are some construction work was undergoing in that area. And during this particular scenario, we have taken again our surveying job, and we provided this result in terms of lat-long operation. So technically, we have converted all the information which is available in that area in terms of our georeference locations. So this system is working very nicely, and we are satisfied with the performance. And when we have compared the results with the ground truth, so 99% accuracy we have found, and there are some minute errors which we have find out, and we are also focusing to remove them. And the important thing which is I would like to share is that the time taken to develop all this method is very, very small. If, for example, some other method of measuring or developing these kind of maps, if someone is taking place, for example, some manual measuring techniques or some stationary scanning based techniques. So this moving system is working very nicely and very rapidly and developing all this information. And in future work, we are targeting also to make addition of some vision information to colorize this information in order to make more better map representations. So many thanks. And if you are having any questions, please, and any suggestions.
Okay, thank you very much for the presentation. It was perfect timing, so thank you very much. And very interesting. Is there any question in the audience? If no, we have time for...
Yes, I have one, if you don't mind. A question about the scanners that you use, the lasers that you used are, can you tell us what the wavelengths are using these type of lasers, and if you use them in continuous wave or in the pulse mode?
Actually, these laser scanners, I'm right now not remembering the correct wavelength, but they are all in those regions which we can use in indoor environments. For example, they are following all safety standards. So I think class 1, they are called actually class 1 laser scanners. So for us, actually, what we are needing, we are just needing that they at least cover 30-meter range, which they are covering. And they should work in that area where some pets or maybe humans, they are available in that region. So that's why we just picked that particular laser scanner.
Okay, thank you very much. Because I was interested in the power that they deliver because of the safety of the people who are okay.
Yeah. This is they are safe. They are class 1 standard.
Thank you very much.
Alberto, if you permit me a very short remark, it's Panagiotis. Yes, very short remark. Okay, by the way, I just remembered in the area of radar that I have been working for many years. We are using 3D laser scanning for example, for making the 3D CAD model of, for example, of trucks or for cars or other objects. And because they make experiments, radar experiments for experimental data and simulated data, and they are needing these 3D CAD models of trucks or cars or other objects, and they are doing this by using 3D laser scanning. So perhaps this might be interesting for the author of this work. Thank you.
Yes, of course. Actually, problem is that the funded amount was limited, so that's why we are having only choice to take a low cost scanner. So we just take 2 scanners in that particular project, and definitely if we are having some more funding, so definitely 3D scanners are more better. So yes, this is true.
Okay.
Thank you.
Thank you very much, Sayed. Very interesting. If there is any more questions, you can address the author and information you can find in his paper. Thank you very much.
Thank you so much.
So next presentation is a humidity and isopropyl alcohol detection sensor based on plastic optical fiber, delivered by Dr. Laurent Zolga from Technical University in Cluj-Napoca, Romania.
Thank you very much, Alberto. I will present my work, and I will start out with some motivation taking this journey to implement such a humidity sensor, and mainly to implement a system that can detect inflammable vapors. This work started out when we had the problem of the chemical faculty 3 years ago, when an explosion was happening because some inflammable vapors had get in contact with some sparks in the lab. So I started out to work on optical fibers. I worked first time on glass fibers, but from the literature we can observe that these type of sensors, temperature, humidity sensors, strain sensors using glass fibers are very expensive because of the interrogators that are used. Usually OSA, optical spectrum analyzers, are used, and they are very, very expensive to do this job. So the principle of operation of such a humidity sensor, it's based on exposure of the core of the fiber. In this case, I use the plastic optical fiber, which is very easy to handle, and mainly because of getting rid of the cladding of the fiber where the vapors can interact with the core of the fiber. What's happening? The critical angle of the fiber inside of the fiber between the core and the cladding will change. For example, when the light is passing through the core of the fiber, if we are changing the index of reflection of the outside medium, for example, from 145, 144 that we have for the cladding, and we are getting to 1.33 for the water droplet, the angle, the critical angle will start to decrease. Because it is decreasing, it means that more light rays which are getting in touch with the water droplets in this space will suffer total internal reflection, and we have more light on the infrared receiver. Because of this, we used infrared emitter and receiver in the 940 nanometer wavelength. We didn't want to have interaction with the ambient light. And now for the setup. To control the humidity, I created a box with the 30 centimeters length on each dimensions, and I distributed inside of this box electronic sensors, well-known electronic sensors like the DHT22. From the data sheet, they are capacitive humidity sensors. They can measure as well with the thermocouple the temperature inside of the box. And after these measurements, the fiber is placed on top of the box, and we have two fibers. One is exposed, so it's the sensing fiber which is exposed. So a part of the cladding is stripped down to get interaction with the humidity, with the water vapors, and the other one it's a reference fiber which is not stripped. And it means that the water vapors cannot interact with the fiber. It means that the signal must be the same on that path. This is the practical implementation of the setup. On the left side, we have the electronic part with all the connections. And on the right side, we have the box where we control the humidity and for the fiber and the electronic sensors. The first task was to see how the DHT22 sensors are working in such a medium, because from the datasheet we have an accuracy of 2 to 5% accuracy of the measurements, and between 0 and 100% relative humidity. They can measure this range of humidity. The distribution of the sensors are on the left side, on the right side, and on the top of the box. We can see that two sensors are working good. So the left and the right side sensor are working well. The first test was done in the same, we didn't change the temperature, so we remained with the room temperature. And the humidity, we didn't introduce humidity in the box. So we wanted to have the same humidity from all the sensors. Because they have a small inaccuracy in the measurements, we can see that we have this data as well in my measurement. To control the whole setup, I did a software calibration of one of the sensors to have the same room temperature and humidity in the constant medium for all the sensors. The next step for the measurements was done introducing humidity in the box, but controlling the humidifier 10 minutes in on state, and after that 10 minutes in off state. As we can see, the red graph is for the top sensor. It means that it's reacting in a longer time because it's on the top, and the left and the right humidity sensors are reacting very quickly, being very close to the humidity source. The last test was done by controlling the humidifier in different steps between 2 seconds, 5 seconds, 10 seconds, and 20 seconds in on state, and after that leaving the setup to stabilize the humidity. In this case, we have 5 seconds on state. So here is the pulse for the humidifier for 5 seconds on state, and after that we have around 2 minutes to stabilize the humidity in the box. All around the time spent from the pulse and to the end to the stabilization, it's around 2 minutes and 10 seconds. All these measurements done for 2 seconds, 5 seconds, 10 seconds, and 20 seconds on state for the humidifier were conducted in this table, and to show the steps, the accuracy of the jump steps. The best one is for 2 second on state. We have a jump step of 0.5 relative humidity jump step. And for the 5 second, we have 1.5% humidity jump. But the reaction time for the 5 second on state of the humidifier is much quicker than for that with the 2 seconds. All these measurements were done around 10 times. So they were repeated 10 times. So it's not only one measurement. I present only one of them. And this is what's happening when I switch on the humidifier for 5 seconds. And after that, leaving for around 2 minutes and 20 seconds to stabilize the humidity, we can see these jump steps for the humidity. So it's between 0.4 and almost 2%. So these are the jumps to have a well-controlled humidity in the box. And now let's see what's happening with the sensitivity of the POF fiber. In the case of the plastic optical fiber, we exposed, first time I exposed 1 centimeter of the core for the humidity, and the both fibers, so the reference fiber is the red one, and the blue one is the sensitivity fiber. We set up the input to have on the receiver around 3.03 volts. So this was the beginning of the first measurement. And after that, when the humidity increases, we can see that the voltage read by the sensor from the infrared sensor start to increase. Till we reach the maximum humidity, we have 3.25 volts on the receiver. This was the first test with the 1 centimeter exposed the fiber. The next one was with 2 centimeters of the fiber exposed to the humidity. As we can see, the reaction of the fiber is much quicker. We can see on this slope. So the reaction it's much better in this case. And we tested out a third one. I tested out with this one with 3 centimeters exposure of the core. And it's very close to what's happening to the 2 centimeter exposure. So this was for the humidity test. And in the end, I compared all these parameters obtained for the POF and for the DHT humidity sensor in one table to see what are the values that are changing and the reaction times for the fiber and for the DHT sensor. From the reaction point of view, they are almost the same. So they react around 30 seconds for the reaction for the humidity. And for the output voltage, when it's for the humidity, for the POF humidity sensor, it goes up with the 0.2 volts when we reach the saturation. And now this setup, after that, I switched to a setup to detect what I was interested into isopropyl alcohol detection for a chemical lab, where they are using this type of solvent. And the first test was done in room temperature setup, where I didn't change the temperature. It was room temperature, and 50 milliliter isopropyl alcohol was introduced in the box. The reaction of the fiber started out after 8 minutes, and we have a small shift in the output voltage for the reaction fiber. So this was done in room temperature. What's happening when we start to increase the temperature? We can see till 55 degrees, we have the same change. After that, between 55 and 70 degrees, we have another change in the output voltage. But in the end, when we reach out after 70 degrees Celsius, the optical fiber start to melt down. So the temperature is too high, and in reaction with the isopropyl alcohol, it starts to melt. The sensitivity, let's say for the POF fiber for room temperature without alcohol, it can resist up to 120 degrees without being affected. But in reaction with the solvents like the isopropyl alcohol, the reaction of the fiber is very quick and it will be destroyed. So it means that we don't have communication length between the emitter and the receiver. So it means that we can detect such vapors. As a conclusion, from this experiment, a 2 centimeter fiber, its exposure of the core, it's more than enough to detect the humidity or alcohol vapors with such a sensor. About the reaction, in some cases we obtain with 12 seconds a better response than the DHT22 sensor, which is a simple one. It's a low-cost one. And another thing, it's that it can be it can be tested. This type of sensor can be tested with other solvents as well. So inflammable vapors as well, like let's say methylpropyl alcohol or other type of alcohols. Thank you very much for your attention. And if you have questions, please let me know, and I will be happy to answer to your questions.
Thank you very much, Laurent, and thank you for being according to schedule. It was very nice presentation. Is there any question from the audience here?
Alberto, very short question. Can I?
Yeah.
Yeah.
Yes,
okay. I'm sorry about what about the frequency, the wavelength of? You mentioned something about the wavelength of operation or the frequency of operation. What about if you could use other frequencies of operation or other possible modes for your interesting experiment?
Yes, I use it. I didn't mention it. Yes, it's a good question. I used it in a continuous wave. So in this setup, I used the emitter in continuous wave, so it was always on to have always a contact with the exposure of the fiber. So it means that being a multi-mode fiber, it means that a lot of light paths are interacting with that surface, and that's why I used not a laser. I used an infrared, an LED, because it's a broadband from the direction point of view. I have a lot of light rays which can interact with the external part of the fiber. So I didn't use the laser, and it's used in continuous wave to always have a real-time interaction on the receiver.
Thank you very much. Thank you.
Thank you too.
I have also a small question.
Yes, please.
I'm a little bit curious if this length of this open piece of the fiber is somehow related to this humidity level. So we see that now the saturation about a 2 centimeter piece. Yes, it's 3 centimeters already doesn't play a role. But guess if, for example, the humidity levels would be lower. Yes, maybe the different length could be, or it doesn't. The question is, does you check what is the relationship here?
Yes, I work on this relationship. I'm still working on this relationship. From the experiments that I presented you, it's I wanted to see how I wanted a quick response from the sensor, from the humidity point of view, and that's why I tried out 3 different lengths of exposure. I started out with 1 centimeter to see what's happening, and I observed that I have a very low response of the sensor. It was much lower than the DHT, than the electronic sensor. So it wasn't that length. It wasn't a proper one, because I wanted a much quicker response than the DHT sensor and the electronic sensor. After that, I switched to the 2 centimeter length, and I observed that it's better than the DHT22 sensor. And after that, I said, okay, let's see what's happening if I go up with a higher exposure, with a longer exposure. And the 3 centimeters, it's not better. It could be that because I already have losses on that length. So this one can be tested out analytically later. I work on this one to test it out analytically in a program to see what's happening on the size of the core, how the size of the core and of the exposure can influence the sensor. So I have two main parameters that can influence the sensor, definitely.
Okay, thank you. Because we have also some group doing in Riga with some optical, but they use mostly telecom fibers for the pressure measurements, and this is these optical sensors, by the way, have very great future. I believe this is very good.
Yes, that's they have a great future. They are widely used, but the main drawback for this moment, all of these sensors, it's the interrogators, because they are working on different principles. For example, Briand effect, Raman effect. All these interferometer sensors they need optical spectrum analyzers. to be sure where is the frequency, where do they react. And because of this, because the interrogators are very expensive, it's not affordable for everybody.
Yes, maybe, yes.
So this is the main drawback for these very good sensors.
Okay, thank you very much,
you.
Laurent. Thank you for your presentation. Thank you for the answer.
Thank you very much.
So we move to the next one, which is Piscivorous bird deterrent device based on a direct digital synthesis of acoustic signals. It is developed by Arturs Abotnis from the Institute of Radioelectronics from Riga Technical University. So Arturs, it is your turn when you want.
Okay, so I cannot share because it's already
Laurent, could you
shared.
please stop the sharing?
Yes, of course. Sorry. Yes.
Okay. Okay, this is. Okay. Hello, everyone. I'm Arturs Abotnis from Riga Technical University. So, not very far from our Lithuanian colleagues. So, unfortunately, this year we still are in pandemic. So, and I'm going to talk about our project about project of Piscivorous bird deterrent device based on direct digital synthesis of acoustic signals. So, so this is seemingly, it could be, seems like a very simple problem. Just we have a birds and we are going to deter them, but it was a quite an interesting, we got some quite interesting result. So this research was funded by European Maritime and Fisheries Fund. And the objective was development of system which deters birds from the fish ponds. And this is a part of this project. And this is acoustical part of this system. And in this part, we explored also such thing as a bird hearing and existing solutions to deterring birds from some places. And we create some algorithmic base for the sound generation and also got some implementation of this. And I'm going to talk about all these tasks. So where is the problem? Okay, let's go with the next. The problem is this, there are some birds which are in recent years, the population of some birds have rapidly increasing. And one of these birds is this cormorants. Yes, this cormorant, the population of the cormorant is, here is a picture. This is a protected bird, which is not allowed to hunt. And this population of this bird is very rapidly increasing, especially in this European territory. And maybe for my European colleagues are already familiar with this problem. And these cormorant families are expanding. They are taking huge territories. And as you see, for example, from these pictures, they are like destroying areas about around some water reservoirs. And very frequently, there are some artificial fish ponds where there are some fish growing inside going on. And if this cormorant start to live at the coast, and there's usually it goes, this number of fishes here go down to zero, and they catch even all small fishes out. And this is a huge problem, by the way, and very huge losses from this problem. And there are, of course, some solutions to this problem. One of them is some typical things like this is called guns, yes, deterring guns, gas guns, where you can install this gas gun on the coast and you can deter, but most of the birds, I would say all of the birds, because cormorants are by far not the only birds living at the coast of all these water ponds. There's a lot of various species, and many of them are hunting, yes, and they get used to these devices. They even can predict these shots, and soon after this shot, they return back. It's also possible to use some nets also over the fish ponds, but if the territory is because many of these fish ponds are quite huge, they're hectare huge, and installation of the nets over such big reservoirs is quite problematic. And of course, people start to use some electronic devices. So you maybe are familiar with such kind of small deterring devices in some buildings when you are protecting not fish ponds but maybe some crops, and this is one of the way how to deter birds. Also, airports is also one very important area where these birds are big problem. In the airports, they use so-called the newest development for the airports. This is so-called parametric arrays. Yes, this is this sonic shield, so-called. Yes, and they use many speakers which emit coherent acoustic waves, so that they produce some field with very big noise. And then in this case, the birds avoid this area because they cannot communicate with each other, and seems that communication between birds is very essential part of their life. And if they cannot communicate, they leave this area. But the drawback of this solution, it is extremely expensive because you need parametric nonlinear speakers, and this is affordable for the airports, but not for the fish ponds. Yes, okay. So what we can do in this acoustic deterring, yes? If we look to the hearing of the birds, they hear in quite a limited frequency range. Most of the birds are hearing like from 1 kilohertz until like in the air, this is 5-6 kilohertz. And so we must emit sound in this range. So some, for example, ultrasonic and so on are not efficient because there are devices that claiming they are deterring birds in the ultrasonic range, but ultrasonic doesn't work in the air. If we look to those species of the birds which are hunting underwater, because this is the problem with the fish ponds, the hearing of those cormorants, this is the red line here, goes until also like 10 kilohertz. But there are some species able to listen unto 100 kilohertz underwater. Yes, this is very interesting how it works. Yes. So, and what we decided to do, we developed some equipment which is deterring birds or in the air and also underwater. And there was a problem with bird habituation to the sound. If we play some recorded sounds, they get habituated very quickly, so it doesn't work at all. And the problem was to get some synthesizer which synthesize sounds which change all the time or variate at least. And the idea was to synthesize some sounds of these predator birds. Yes, and so this is an ambitious task to synthesize biological sounds. And we look to some methods here, what we can use. This pulse code modulation, this is just direct recording of the sounds. This is not very efficient because you cannot easily modify the sound. You can play the same. This is very easy. You just put the player, but gets habituated, or you have to have huge library. This is a wavetable synthesis, classical method when you use some pre-recorded simple sounds. It comes from the music industry. And one of the most interesting methods is a frequency modulation synthesis. This frequency modulation synthesis, when you use one wave which modulates other, for example, one sinusoid modulating another sinusoid, and if the frequencies are close to each other, yes, then you can get very interesting effects. And this effect was noticed by this Mr. Chowning in '73, who developed this FM synthesizer, which was later commercialized by Yamaha, and it was extremely popular musical synthesizer. This was done at this university get a lot of money from this patent. From this, it was not patent, it was some agreement about use of this development. And there is a of course, some ways of simpler ways to synthesize. This is so-called direct digital synthesis, which is used in many frequency synthesizers, also for radio communications and so on. In this case, you change the frequency quite slowly, so the modulating frequency is much lower than the carrier, and in this case we can say this is very large modulation indexes, and there's no such much interesting effects, but you can easily control the synthesizer. And of course there is a multi-tone DDS. In this case you can synthesize various sounds including voice and so on, but it becomes quite complicated as well. So what we decided to use this simple DDS, direct digital synthesis. In this case, because of the availability of devices which do this, namely it was this analog devices AD9850, which is quite popular synthesizer working up to 30 megahertz, yes. And we controlled this chip, in what it was a board, in fact, which we used with some specific microcontroller program. We developed some protocol for the storing sounds, which are able to control this duration of the segment, frequency, amplitude, with some resolution. And in this way, we was able to synthesize many birds songs, yes, and quite similarly to the natural ones, with very compact design and very few much lower memory use, yes, because you use, this is like we just store the sequences but not the samples of the sound. And this is there is some problem, because if we wish to synthesize natural sounds, we have to convert some PCM records of the existing sounds. So we developed some algorithm in which we convert PCM sounds, recorded sounds, which are quite noisy sometimes, to this synthesized sequences. And if the sound, many birds has this one major frequency in the song, so it is easy convert. But some birds have two, for example, and in this case, this method has a difficulties, and we have to use some filtering to avoid jumping between two frequencies. It was like a little bit funny when you hear it when it jumps between two.
Sorry, we have the 2 minutes.
Okay, yes, I will finish. This is an algorithm. Here we read audio file, calculate spectrogram. From the spectrogram, we calculate the maximum frequency. And by the way, this method is I think for you looks quite straightforward. Here the hints are dealing with the noise. The noising of the signal is the most difficult part. And then we created those sequences. And here is a picture how it looked at the end. It was a ready board with this AD9850 on the larger board. Yes, it's this part. It has several other microcontrollers for the some other tasks. And the final look of the systems. This is here. This is a ground-based system with a speaker, also the laser, because this is optical complement for this system, and also floating system, which is acoustic over in air and also underwater speakers at the bottom of this device. The results show that it works. However, without the optical part, it is not that efficient. Yes, this optical part is very important. Yes, by the way. And but anyway, we developed some technology for the sound generation, and we can generate biologically relevant sounds and synthetic sounds, and we can join with some smarter systems in the future and have like maybe some kind of very adaptive and intelligent sound generation. And we could prevent the habituation of those birds. So thank you very much.
Okay, Artur, thank you very much for your presentation. So we have time for a very fast question, if any. Is there any question from the audience? Okay. Well, thank you very much again. Sorry, I will go to the next one because I would like to keep in the schedule. Okay. Thank you, Artur. It's very interesting. Thank you very much. Okay, so the next one is going to be efficient feature set development for acoustic gunshot detection in open space. And presenter is going to be Milan Sigmund. So Artur, if you could, thank you. Milan Sigmund, hello and welcome. And when you're ready, you can start. Thank you very much. No, Milan. I'm afraid we cannot hear you. Can you hear us? Sorry, Milan, we cannot hear you.
Maybe it is better to go with next presentation, and Milan will solve his microphone issue.
Yes, sorry, Milan. We're going to pass to the next presentation, if you don't mind, and then we will get back to yours once we solve this problem. Okay, so next one, if you are ready, Shindong, are you there?
Yeah, I'm here.
Okay, thank you very much. So next one is going to be advanced calculation model for V-belt temperature field, and it's going to be presented by Shindong Ni. Okay, so Shindong, whenever you're ready.
Yep, I'm ready. So let's give him some time. And can you see me? See my screen?
Yeah.
Okay. Okay, hello everyone. Thank you for your time listening my report, and it's my great honor to give a presentation here. And my name is Ni Xindong. I'm a PhD student from China Agricultural University. So let's begin the presentation. And my topic is advanced calculation model of V-belt temperature field. And I will expound my research as the following 5 parts. So as we know, most of transmission on the combined harvester is realized by belt transmission. So V-belt is the most crucial part of power transmission. However, in the process of continuous high strength operation, surfing hardening, brittle fracture, and other features are appeared on V-belt due to the temperature rise, which seriously affects service life of belt and stability of the whole machine. Therefore, research on the temperature field of wheel belt is of great significance to improve its service life. In the process of summary and analysis, it is found that there is a strong correlation between dynamic heat and the power loss of belt drive. At present, existing researches mainly focus on the theoretical modeling and the experimental optimization method of power loss of FEAD system. FEAD is from an engine accessory drive. Well, there are few reports about the calculation of temperature field. Therefore, based on the calculation of wheel belt power loss, we establish an advanced calculation model of wheel belt temperature field through finite element calculation and experimental verification. So before calculating the temperature field of wheel belt, heat source.
Teď to funguje. Jste špatný vstup zapli. Máte tam hodně těch dírek vzadu, tak to prostě píchlo na jinou.
Milan, we can hear you now. Okay, thank you very much. Okay, Ni, you can keep.
Okay. So before calculating the temperature field of wheel belt, heat source of temperature rise must be analyzed and quantified. It can be seen from the relevant literature that heat source of the temperature rise of wheel belt come from internal friction and the external friction. The internal friction heat source is caused by hysteresis response of rubber. Among them, dynamic bending is the main component of internal friction heat source. During load transfer process, wheel belt is periodically ruled in and out of pulleys. Because of limitation of pulley geometry, wheel belt will be bent and spread periodically, which will cause dynamic bending of wheel belt to generate heat. Well, external friction is caused by the elastic sliding of the belt on the sliding arc. So after determining heat source of temperature rise, then the next step is to quantify the heat source value. In this paper, dynamic analysis software AVL XITD is used to complete modeling, simulation analysis, and power loss calculation of wheel belt drive system. It mainly consists of four steps. The first step is to set the physical parameters of pulley and belt. The next step is to set the parameter of tensioning mechanism. And the third step is to set the drive speed and load. And finally, we can calculate the heat source value of specific conditions. In our research, a wheel belt drive system harvester is taken as the research object to calculate temperature field of wheel belt. Calculation model of temperature rise and heat source based on AVL XITD is shown in the red picture. This picture. So in order to explore the heat source calculation results and the rules of wheel belt under different conditions, we chose 10 different conditions to conduct comparison. In the change of working condition 1 to 5 is the speed of driving pulley, while the change of working conditions 6 to 10 is driven wheel load. When the driving pulley speed is a single test variable, heat source calculation results are shown in the left picture. It can be seen from the results that most of heat sources of wheel belt come from internal friction, and the proportion increases with the increase of driving speed. Because bending frequency of wheel belt increases with the rotation speed of driving pulley, which causes the hysteresis heat of the rubber to increase. When the load of driven pulley 2 is a single test variable, heat source calculation results are shown in the red picture. It can be obtained from calculation results that although the internal friction accounts for a larger proportion of total heat source, The proportion of external friction heat source gradually increases as the load torque of driven pulley 2. Now, after obtaining heating source calculation value, according to energy conservation equation and Fourier heat conduction law, the balanced equation in steady state can be listed, where alpha is heat flow distribution coefficient between V-belt and pulleys. PFN is total external friction heat source between V-belt and pulleys. pH is internal friction heat source value of V-belt. ABR is contact area between outer surface of V-belt and air. HB is equivalent thermal convection coefficient of V-belt. TB is steady state temperature value of V-belt. TA is reference temperature. In three-dimensional dynamic heat transfer model, bending internal heat source acts on V-belt in the form of body load, and the external heat source acts on sliding contact surface in the form of surface load. In order to reduce the amount of calculation and improve simulation efficiency, three-dimensional dynamic heat transfer model is equivalent to two-dimensional static. The internal heat source body load is converted into a surface load, and the external friction surface load is converted into a linear load. Then the temperature field is solved by finite element method after meshing and calculation. The results show that the temperature of V-belt increases gradually and tend to be stable with the increase of driving pulley speed or load torque. In order to verify the temperature field calculation model of V-belt, the setup composed of transmission system and the measurement and control system are developed. The measurement device mainly includes Hall speed sensor, non-contact infrared temperature sensor, and the torque sensor. Hall speed sensor is used to measure speed of driving pulley. Non-contact infrared temperature sensor is used to measure temperature of V-belt under different working conditions. Torque sensor is used to obtain the load torque on driven pulley 2. The control equipment mainly includes frequency converter and the magnetic powder brake. Frequency converter is used to control angular velocity of driven pulley. Braking torque is applied to driven pulley 2 by means of a magnetic powder brake. The braking torque of magnetic powder brake is regulated by a controllable power supply. Motor controller and the controllable power supply are connected to CAN bars through serial port to CAN module. Data measured by Hall sensors, infrared sensor, and torque sensor are processed in microprocessors to be converted into digital data. And data from CAN bars is transferred to computer using a data acquisition software developed by LabVIEW. And the experiments are conducted in the indoor environment with 16.2 ambient temperature and 18.4 relative humidity. Compared with the simulation results, temperature rise trend of V-belt is consistent. From the beginning, the temperature of V-belt increases rapidly, then increases slowly, and finally tends to be stable at the same speed level or torque level. At different speed levels or torque levels, the steady state temperature value of V-belt becomes larger as the speed increases. This phenomenon can be explained that from perspective of heat generation and heat dissipation of transmission belt. At the beginning of the test, convective heat transfer between belt and air is small, and most of heat sources are used to increase the internal energy of the belt. Therefore, the belt temperature rises fast. In unsteady state process, with the increase of temperature of belt, the convective heat transfer intensity between belt and air gradually increases. The heat source value used to increase internal energy of belt gradually decreases, and the temperature rise rate of belt gradually decreases. In steady state process, the total heat source value of belt is equal to convective heat transfer value between belt and air. Internal energy of belt doesn't change. The temperature of belt doesn't change either. So in order to evaluate the accuracy of simulation model, delta T is set as the comparison in this paper. In any case, delta T first increases, then decreases, and finally stabilizes. The whole process can be divided into two stages, unstable process and stable process. It is an unsteady process in the range of 0 to 475 seconds. In this process, the maximum value of delta T is 3.43 when driving speed is a single variable. Well, the maximum value of delta T is 4.77 when the load torque is a single variable. After 475 seconds, there is a steady state process. In this process, delta T tends to be stable. We can find that the difference between calculated value and the experimental value in unsteady state process is larger than that in steady state process. This is because only the heat flux distribution of friction heat between belt and balls are considered in the simulation of unsteady state process. And the influence of heat conduction between belt and pulleys are ignored. After heat flux distribution calculation, 93.4% of external friction heat is used to increase the internal energy of pulleys. And the specific...
we have 2 minutes to go.
Okay. Oh, sorry. The 90.4 of external friction heat is used to increase the internal energy of pulleys, and the specific heat capacity of pulley is 3.7 times of that of the belt. This will cause the pulley to have a higher temperature value than belt. Due to temperature difference between belt and pulleys, some of that will flow from pulleys into the belt. Therefore, in the unsteady process, test temperature will be higher than simulation temperature. And sorry for too many time. And here are the conclusion. And thank you for listening. And if you have any problems, just email us.
No, we still have time for if you want to finish with the conclusion. We have a minute. But if there is any question for me from the audience. Any question?
I have a small question, maybe.
Yeah. Okay. Yeah.
I'm not a big specialist in mechanics, but now it seems like temperature will increase until infinity. Yes, but or not? How it was in this model? Yes, I do not see the temperature saturation. It's at some moment, no? Or I missed it because this delta T was always positive, no?
Mm-hmm.
In this, no, maybe go to the previous slide. Oh no, this. This. No. Where is the plot? Next one.
The police.
No. The next slide.
Oh, next slide. Okay.
No, the next. There is a. Where is a plot?
The next one.
It's graphs. Okay, graphs. Is a temperature.
Temperature.
Mm-hmm. No, it's temperature from time. It was some plot here and looked like. Could you please show the next slide? Maybe there is not numbers. This one, yes. It seems like temperature goes up all the time.
Yeah. But after the temperature will increase rapidly first, and increase slowly, and it will tend to be stable here.
Yes, maybe it's some while become flat, because now it looks like it will increase.
Yeah. In this picture, it likes always increase.
Okay, thank you.
Okay, thank you very much. Thank you for your presentation and the questions. So we're going to move to the last one, which is efficient features development for acoustic gunshot detection in open space by Milan Sikmuk. So Milan, whenever you're ready, you have 13 minutes and then 2 minutes for questions. Okay, thank you very much.
Okay. Good morning. Can you hear me?
Yes.
Oh, yeah.
No, you just have to go to the PowerPoint you have in the background.
What?
This one, yes.
Okay. I will start it. So my presentation deals with gunshot detection in open space. The presentation is divided into slides. We start with introduction, then some short characterization of gunshot sound signals, our principle of gunshots detection, then the two sets which we use. They are optimized Gapster coefficients and time domain based feature set. And follows slide with evaluation criteria and achieved results. And finally, brief conclusions. In the field of gunshot detection, there are many systems, commercial systems for use in military and for urban and in-building application. Our work and development is focused on different situation. The motivation of our work was collaboration with international association named Safe Elephants. They are elephant herd in Africa equipped with special collars with GPS module to track the movement of elephants. And our idea is to complement the collars with a special gunshot detection module that can send an alarm signal together along with location information. And in such a case, the game ranger can very promptly act. The basic characterization of gunshot sound signal is that they are impulsive signal with very high intensity, around 160 decibel, and with a short duration. This is mainly, in most cases, shorter than 10 milliseconds. We can see left typical gunshot signal in a time domain and the spectrum of this signal. The waveform consists of two parts. The initial part is typical has typical an N wave with symmetric oscillation, and the second part is the decreasing oscillations. In spectrum can be seen some local peaks in the range 0 to 2 kilohertz, and the main frequency components are between 250 and 450 hertz. The basic principle of gunshot detection is as follows. First step, the amplitude is normalized in range from -1 to +1. Then the signal is segmented into short frames, usually 10 milliseconds, with overlap 50%. And we use a combination of two feature sets, linear frequency Cepstral coefficients and time domain based feature. These feature sets are fuzzied, and the next step is recognition or classification. We use neural network consisted or structured in two hidden layers of 20 neurons each. In the training stage was used 600 gunshots and 6 times 600 non-gunshots, and in testing 700 gunshots and 6 times 3,200 non-gunshots. The sum of non-gunshots or the sounds is divided in 6 categories. This is the means, while I write here 6 times 700 or 6 times 3,200. The first set of coefficients are optimized Cepstral coefficient. The block diagram in the left shows the calculation approach. Input is audio signals, then is the segmentation or framing, short-term fast Fourier transformation, and the next block is linear filter bank. This block is the core of our optimization. We use gamma tone filter form, linear spacing of these filters in the range 0 to 16 kilohertz, and this frequency range is divided in 31 bands or filters, and we calculate 18 coefficients. The formula for calculation can be seen in the bottom left. The figure right shows the entire filter bank. The second group or set of features are shooting specific features. We use the time interval T between two dominant peaks, between the positive and negative peak. Area P, this area is bounded by the peak-to-peak curve and the horizontal axis. Then area A, this can be seen here. This is the area between the positive curve and horizontal axis with the duration 6 milliseconds, and similar is the negative area B, and the last feature in this set is the ratio of areas A and B. In the evaluation, we use two metrics. They are typical or frequently used metrics in binary classification. They are true positive rate and true negative rate. The equation for the calculation can be seen in the left part, where TP is number of true positives, that is when gunshots are identified as gunshots. Tn is number of true negatives. Non-gunshots are identified as non-gunshots. FP, number of false positive. It is this situation, or this number of cases is known as also as fault alarm. In this case, non-gunshots are identified as gunshots. And the last, Pn, number of false negatives. In this case, the gunshots are missed. The results, first, we have compared only the set of linear frequency Krebs-Strahl coefficient with other Krebs-Strahl coefficient, male frequency Krebs-Strahl coefficient. This kind of coefficient is very popular generally for recognition and detection of audio signals. The optimized number of MFCC coefficient was 12, and the frequency range 0 to 22 kilohertz. And in the case of linear frequency coefficients, a group of 18 coefficients and frequency range 0 to 16 kilohertz. We can see in this table that the LFCC gives better results in both categories. And the second table shows separate results of true positive rate and true negative rate for LFCC, for the second group TDF, and then fused both feature sets as in single neural network and in ensemble neural network. the best results are slightly above 95% true positive rate and 98% of true negative rate. In the test, we have used it.
Sorry, Milan, we have 1 minute and a half, 1 minute, 30 seconds, okay?
Okay. We have used it various hunting weapons in 6 different classes of non-gunshot sounds. These 6 classes are barking dog, sound from elephants, sound from rain and storm, car horn, engine sound, and human sound, including short shouts. And the conclusion, comparing to other methods, they are based on monochannel signals. We are slightly below the absolute maximum that was published, but the good advantage of our method is that 98% of environmental sounds was ignored. And from the point of implementation, we use a relative simple neural network. So thank you for your attention.
Okay, thank you very much, Dr. Simon. Is there any question from the audience? Any question? Nothing? Just, okay, thank you very much. I'm sorry, but the next session starts in 20 minutes, so I think it is better to stop now. So you can have a small break for the next session. Okay, thank you very much for all the presenters. And thank you very much for the audience, for your attention and for coming.
Thank you, Mr. Chairman, for chairing.
You're welcome.
Thank you very much. Thank you very much. It's very good. Thank you.
Thank you, Alberto.
Thank you.
Alberto. Let's keep in touch.
Okay. Lodek, nice to see you.
Have a nice day. Alberto, let's keep in touch.
Yes.
Best wishes. Yeah. Nice to meet you. See you
Nice
later.
to meet you. Nice to see you too. Nice to see you too. Okay, Darius, should we close the session? Should I exit?
Yes, you can just exit. And Professor Bogdan Midzinski, chairman of the next session, already joined.
Okay.
I discussed with him a bit. So
okay.
I will wait for next participants, and I hope everything will be okay.
Okay, good.
Okay. Thank you.
Good. I have a busy day today. I have to go to the doctor. I have to get my vaccination. I have another meeting.
Take care of yourself.
Yeah. So we'll keep in touch. Okay. I hope
yes.
Today or tomorrow, because I would like to ask you a few things. Okay.
Okay.
And I try to attend tomorrow morning to some sessions.
Okay. Thank you. Bye.
Bye.
Can I share?
Okay, we can start. Let first tell me that the first paper will be given by you. That's Sveti Hranov. That's from Department of Power Electronics, Technical University of Sofia, if I'm not wrong. Okay, and the paper is no tolerance. It's not this paper. Tolerance. You change the title.
Oh,
I have the title. I have a tolerance analysis.
Yeah, I have used the template twice. Okay, so yeah, we'll start from here. I'm sorry.
Okay, it doesn't matter. Doesn't matter. Okay, tolerance analysis of common transistor DC-DC converter.
Yes.
Okay, are you ready to have a presentation?
Yes, I'm ready.
Therefore, please go ahead and please don't mind that you have 15 minutes for presentation and 3 minutes for discussion. Please go ahead.
Okay, so my name is Sveti Hranov and I'm going to present our paper. It's about the influence of the operating regimes on the dynamics of a series resonant DC-DC converter. An assessment.
Sorry, I see your introduction. Okay, the title. Put title since for everybody to know what I'm talking about.
I haven't changed.
Oh, it doesn't matter. It can be.
Yeah.
It can
Yeah.
be. Okay.
Yeah. So let's get on with it. An assessment was made of the duration and nature of the transients, both in terms of the output voltage and in the resonant inverter, and optimal values of the parameters are determined in order to obtain the desired transient processes. This is the experimental setup. And a laboratory evaluation module kit is used. This is the model of it. It is from Texas Instruments with the following parameters: input capacitors, resonant inductor, resonant capacitor, output capacitor, and then the inverter transformers parameters are as following for the primary winding and the secondary winding. This is the circuit, the power circuit schematic, and this is the digital control of the converter. So the test methodology is initially the transients of the converters were examined and found the optimal starting frequencies so that the output parameters were nominal. Then a study of the transient with fixed frequency but different output currents was made. The transient at different values of the output capacitor are also taken, and finally a study was made at fixed output parameters and starting frequencies in the form of equal percentage steps below and above the optimal for the given mode of operation. And this study is equivalent to the study of the influence of the tolerances of the resonant elements on the operating mode of the converter. So these are the results. On the first graph, figure 3, it can be seen the nominal starting frequency at nominal loads. Then the second study is different loads at the same frequency. It can be observed that the transient process isn't changing very much, so it is, so to say, independent of the load, but the form of the transient is nearly the same. Then the different output capacitor values are changed and the transients are observed. Note that these are taken from real hardware and processed in MATLAB for clear view. However, these are from a real experiment. That's why the values are so. And here is a study at same current, same load at different starting frequency to see how the transients are going. So this is a table summarizing the output values and their nominal values and how fast they settle the transients to the steady state mode, also by changing the capacitor voltage. And yes, the discussion and conclusions of the results by changing the value of the output capacitor and the starting frequency. The change of the operating mode indicates that the influence on the dynamics and the type of the process in the converter, the effect is greater on the elements of the resonant inverter than in the high frequency rectifier. And using a suitable choice of starting frequency and value of the output capacitor is achieved on one hand a periodic nature of the transients, and on the other hand a shorter duration of the transient process. The results of the study of the influence of the starting frequency are interesting. The starting frequency is important factor in achieving good dynamics and nature of the transients, and it is important in point of view of the setting the controller parameters and system for initial startup of the device, such as soft start, and the result can be used as methods for designing power electronic devices and optimization of the transient process. This project is supported by the European Regional Development Fund. Operational Program, Science and Education for Smart Growth, National Center of Mechatronics and Clean Technologies. Thank you very much.
Okay, thank you very much. Oh, you did very quickly. That's okay. Thank you very much. Any question from audience? Question from audience? Okay, may I have a question? You know, that's interesting work. You know, that's however, that's very interesting guide for designers.
Yeah.
And let me know what kind of converter DC-DC you found is the most sensitive for the changes of parameters.
So this paper is about the AOC resonant converter, but the most sensitive from my point of view is the boost converter.
Boost converter, okay.
Yes, the boost converter is extremely sensitive and the operating regimes are very, how to say, tough. I mean, the initial startup currents and the dependence of these currents, especially from the inductor current, from startup frequency, from circuit elements, and also from the load, are extremely sensitive from any of these parameters. Yeah.
Okay.
The boost converter is the hardest converter, I can say.
Oh, okay. Okay. Thank you very much. The question from audience. If I don't see, thank you very much. Thank you very much again. Forgive me, but I have forgotten to introduce myself. My name is Bogdan Miedziński. I'm professor from Wrocław University of Science and Technology, Wrocław, Poland. Okay. Therefore, we will go to the next presenter. I don't know if next presenter is already present. It's Ali Ozil from Turkey.
Yeah, I am here.
Okay. Are you professor or are you doctor? Professor?
No, I'm a research assistant.
Okay, fine. Are you ready to have a paper, to have a presentation?
Yeah, I'm ready.
Please go ahead. This the title of its presentation is Design and Analysis of a Rotor for 22 kilowatts transversely laminated anisotropic synchronous reluctance motor. And presentation will be given by Ali Ozdil from Department of Electrical Electronics Engineering from Karcher Ahi Evran University, Research Assistant Karcher. Please go ahead. You have a little bit more time, you know, since you have a time 10:30. Okay, please go ahead.
Thank you very much. Good morning, dear colleagues. I'm Ali Ozdil from Karcher Ahi Evran University. Today, I'm going to present our study titled Design and Analysis of a Rotor for a 22 kilowatt transversely laminated anisotropic synchronous reluctance motor. Here, first of all, I would like to indicate what my presentation consists of. I'll begin with the motivation of this study. Then I'll give very brief information about synchronous reluctance machines in the introduction part. It will be followed by the design of the generated synchronous reluctance machine. Having demonstrated the design of this machine, I'll show the results of the analysis of the generated machine. And in the end, I'll compare the results with the same powered induction machine in the conclusion part. Now let's talk about the motivation of this study. The reasons that allow us to better understand the importance of this study are shown here. Energy consumption in all around the world has significantly been increased in recent years, and most of the energy consumed at the industry. In the industry, electrical machines take the lead in this regard. Among the electrical machines, induction machines are highly preferred due to their simple construction, but their efficiency is not good enough. On the other hand, permanent magnet synchronous machines are also utilized in industry, but the magnets used in their structure are really expensive. That's why we need to generate a machine with a higher efficiency than induction machine, and having a lower price than the permanent magnet synchronous machine. And this machine is synchronous reluctance machine. Synchronous reluctance machines utilize the reluctance concept and the rotating sinusoidal magnetomotive force, which can be produced by the stator of the machine. Torque generation is based on the difference of the reluctance of D-axis and Q-axis. Now I can explain what the reluctance is. The magnetic reluctance is basically the opposition to the magnetic flux. So let's come back to the torque generation. The equation for the electromagnetic torque is shown in here. Here, P represents the number of pole pairs. LD, LQ, ID, and IQ are inductances and currents for D and Q axis respectively. If we generate a synchronous reluctance machine with the same power, with the same powered induction machine, we generally use the same stator structure with the induction machine. In the synchronous reluctance machines also have the same stator and rotor poles. Having said that, I want to talk about how magnetic field is produced in synchronous reluctance machine. In this type of machines, field is produced by a sinusoidally distributed windings in a slotted stator. Rotor doesn't produce any field by its own. The only link between the rotor and the stator is the small air gap. Rotor will try to align itself, itself with the sinusoidal magnetic field, and when it wants to achieve, it starts to synchronously operate. In this page, I want to talk about the saliency at last. Saliency is a crucial parameter in the design of synchronous reluctance machine, which is the ratio of D-axis inductance to the Q-axis inductances. Now I want to talk about the types of synchronous reluctance machines. Since we use the same stator structure with the induction machines, we can classify the synchronous reluctance machines based on their rotor structure. And we classify them into three groups: salient pole, ALI type, and TLI type. Salient pole synchronous reluctance machines, as you can see from the figure, has a simple construction, but their saliency ratio is not good enough to give a competitive performance with the rest two. Between the rest two, in this study, we choose the TLI type synchronous reluctance machines, and the reasons for that are listed here. TLI type, TLI means transversal laminated anisotropic. Synchronous reluctance machines are more suitable to manufacture because we can punch them as a whole like other traditional machines. This type of machines has less torque ripple and less iron loss than ALI type synchronous reluctance machines. Besides, these type of machines can easily be secured, and sometimes their production manufacturing price can even be cheaper than the induction machine because casting is avoided in that type of machines. Now I want to jump to the design of the generated machine. You can see on the table the specification of our design. Our machine, the power of our machine is 22 kilowatt. The machine operates at 1500 RPM. Our machine, the winding of the machine is delta connected, as you can see here. The pole number is 4, and the diameter of the part of the machine are listed here. So if we jump to the next slide, here you can see the winding shim of the of our design. As I said before, we use the delta connection. As you can see from the figure on the left, our machine has 36 slots, and each slot has a layer, one layer. The utilized number of conductors per slot is 25, as indicated in the table as turns. We use 4 times 0.95 millimeter wires in the windings, and the slot fill factor is, we obtained the slot fill factor around 60%. We try not to expand this value because for an experimental search, it would be impossible to realize if we beyond the slot fill factor 60%. So here in this slide, you can see the final design overview of our generated machine. As you can see the half of the machine. We use during the analysis the half of the machine because it helps to save time us. And as I said before, our machine has 4 poles, and each pole, as you see, each pole has 4 barriers, 3 radial ribs, and 4 tangential ribs here. In the analysis, we use the Dirichlet boundary conditions. We set the potentials, vector potentials at 0 at the boundaries of stator, rotor, and the shaft. And this ensures that the flux lines are parallel to the boundaries. Because besides, we set the temperature as 75 Celsius degrees. In this air gap, the magnetic field changes dense, so we use dense mesh here, but for the stator yoke, as for example stator yoke, we use the coarse mesh to save time again during the analysis. Now I want to talk about results of our analysis. The first analysis that in our study is the effect of the current phase angle. We analyzed our machine between 25 degree and 60 degree. As you can see from the figure on the left, the blue lines represent the torque and the red lines represent the efficiency. We obtained the highest efficiency at 45 degree. However, the highest efficiency is obtained at 25 degree. On the right-hand side, you can see from the table that the current phase angle also affects the input and output powers. And as you can see here, the optimum value for our design is, we choose the 30 because it has a competitive efficiency and we started with the 22 kilowatt synchronous lactus machines. As you can see here, the output power is so close to 22 kilowatt. So in the next slide, we analyze the effect of number of flux barriers to the machine performance parameters, which are torque and efficiency. We obtain the highest torque and the highest efficiency for BS is equal to 4. BS represent the number of flux barriers here. We didn't analyze the geometry with 1 and 2 flux barriers because they don't have a sufficient torque and efficiency. So that's why we analyze between 3 and 5. Among these values, the optimum value is, as you can see from the table, is 4. The next analysis of the generated machine is the effect of the starting diameter. The adjusting starting diameter is important because it helps to regulate the barrier endpoints, which directly affects the ripple. So you can see on the figure, we add the torque ripple here. The change on torque, as you can see, as we move away from the shaft in this way, torque slightly decreases. The change in ripple and efficiency is nonlinear. And the effect of the starting diameter to the power loss, saliency, and the power factor is also represented in the table. Although we obtain the highest efficiency, although we obtain the highest torque for 33 millimeters and the lowest torque ripple at that value, we choose the optimal value as 35 millimeter because the main aim of this study is the efficiency. So we obtain the highest efficiency at that value. Final thing in this slide, I want to talk about the effect on saliency and cosine phi. As you can see, saliency and cosine phi change non-linearly because LD and LQ are affected non-linearly, and it's you can see on the torque this. If we jump to the next slide, in the following two slides, I will demonstrate the effect of the ribs to the synchronous reluctance machine's performance. These ribs are crucial during the design of the rotor of synchronous reluctance machines because these ribs provides mechanical strength to the rotor and prevents barrier from breaking. However, they cause to torque reduction. Now I want to talk about the effect of radial ribs. As you can see from the figure on the left, the torque decreases as the width of the radial rib increase. Here, the efficiency of the machine only changed 0.6% in between 94.5 and 95.11. As you can see also from the figure, the torque ripple increase as the radial rib width getting larger. On the right hand side, you can see on the table the effect of the width of the radial rib on power loss, saliency, and cosine phi power factor. We choose the optimum value as highlighted in yellow here, 1 millimeter, because as you can see on the left, it has the highest efficiency and torque is around desired values. So in the next slide, I want to talk about the effect of the tangential ribs on machine performance. Comparing with the previous figure, you can see the effect of tangential ribs on torque. You see, it is significantly decreased by the increase of tangential rib. The general behavior of the efficiency is that efficiency increases as the width of the tangential ribs wider. Again, the torque ripple has a nonlinear change here. On the right hand side, again, you can see the effect of the width of the tangential ribs on performance parameters, other performance parameters. We choose the optimal value here, 1 millimeter. The reason for that is, as you can see, efficiency increases for the beyond values, but as the width of the tangential rib increases, the output power started to decrease. And since we are dealing with the 22 kilowatt synchronous reluctance machine, this is the optimum value. In the last step of our study, I compare our results with the same powered induction machine. And we can understand they have same power from here. Their torque are similar to each other. Although induction machine has lower torque ripple than synchronous reluctance machine and higher power factor than synchronous reluctance machine, if you can see the efficiency, our generated machine is much more efficient than the induction machine. Here is the final results. In our study, we had an efficiency improvement 5.76%, which improve the class of our generated machine from IE1 to IE4, which is really good. The efficiency improvement is caused by this less power loss. Since synchronous reluctance machine doesn't have copper in the rotor part, they have less power loss, and that's why the efficiency is improved. And also in our study, we obtained a really good salience ratio, 12.69. The only disadvantage in this study is the high torque ripple. Torque ripple value is 9.6% higher than the induction machine. So thank you for the attention.
Oh, thank you, Ali, very much for a very interesting presentation, very interesting paper. Now the paper is open for discussion. Any question from audience? Any question from audience? That's a good way, since you know that nowadays the machines with magnets are being widely used, but you know we have to remember that permanent magnets are not only expensive but also very sensitive to influence of external conditions like stress and like a temperature. First of all, neodymium magnets are very sensitive for the temperature, therefore to avoiding it is a good idea. However, my question is, since this structure is a little bit sophisticated, have you tried, since I think that I expect that it was your theoretical considerations, have you tried to make a model and try to go to just measure it and compare some of your results from the theoretical conclusions and the practical conclusion, or no?
You mean the experimental search?
Yes.
No, I haven't done it yet, but
yeah.
We are. It's in the process. We will try to do it as an experimental search. So we are in a contact with a firm in Turkey. So I'll do the experimental search. I just did the finite element analysis.
Okay, understandable. Any questions? If not, therefore, thank you very much, Ali, for your very interesting paper. Thank you very much. Thanks a lot.
Thank you.
Now we move to another paper. Another paper will be given by the colleagues from this cooperative paper. It's a cooperative paper by Jorge Rafael González Teodoro, Vladimir Kindl, Michał Friwalski. This title is Different Eddy Current Effects, a Study for Circular Winding Based on Finite Elements. Presenter will be Professor Friwalski.
Okay.
Are you ready, Michał? Please go ahead.
Okay. So thank you for introduction. This paper, as was mentioned, was done with the cooperation with the colleagues. I would like to maybe excuse for the presentation because it is a main contribution of the George, who was not able to present this paper. So I will try to substitute him and to inform you as the best for the audience, because he has some family problems. So what is the purpose and topic of this paper? It is related to the problematics of the eddy currents for which are existing in the high frequency components. The high frequency components, I mean here the inductors or transformers, and the phenomena related to the skin depth. And just a second, sorry. Okay, so the problems related to the skin depth, so it is related to the skin effect for high frequency operation, is then in a very close relation to the eddy currents. The eddy currents can cause some problems, you will see later, and the problems are related to the decrease of the effective conduction or surface conduction area of the wires, which are used in the inductive components. Here we are presenting some kind of simplified analysis because it is considered that the circular windings in finite element analysis could be replaced by let's say hexagonal or dodecagonal or octagonal replacement to reduce the computation requirements. So here you can see the representation of the circular wire. So it is the top of the figure, and its replacement by a hexagonal wire. The hexagonal wire is replaced due to the mesh generation in finite element analysis softwares, because the less let's say points, or the simplified or the less components of the computation mesh, then you are reducing the computation requirements and computation time. There is some very important issue if you are reducing the complexity of investigated component. Here you can see that we have the interpretation of the magnetic induction, or otherwise it is also a current density in the circular or in the hexagonal winding, and you can see that there is a different area if we compare these two results. So it means that also skin depth, which is defined by this equation, is being changed if we are considering a different shapes of the replacement of the wire in the software. So this relation or this effect could be visible also if we consider a different operational frequency. So you can see how the skin depth is being changed for the individual replacements of the circular wire. So the more points you have, then you are approaching closer to the original component. So, because the finite element analyses are particularly very complex and require some high computation time and also equipment, it is good to consider with some mathematical approach how to optimize the calculations procedure. So it is important to find the relationship where or how it is able to calculate the skin depth based on the mathematical approach. So here we have some you have a picture where we have some definitions on the magnetic induction for circular winding, and then for the magnetic induction for hexagonal replacement. And this approach is related to find the relationship between skin depth for circular and for replaced component. So the more detailed description could be found also in the paper, or in the proceedings. And after some investigation, we have found that the polygonal skin depth is proportional to the circular skin depth. So it is given by this equation. And it is inversely proportional to this is a constant apole, and it is defined as a ratio between the area of the circular and the polygonal cross section. Okay, so it is the relation between these two areas. Okay, now if we found out this relationship, we are able to determine the skin depth and also the current density in the cross section of the conductor. And also we are able to investigate the side effect in the components or inductive components operated at high frequency operation. This side effect is related to the current loop effect, or otherwise a proximity effect. Because if we have a coil where we have the alternating current, then the distribution within the one analyzed winding is constrained to a smaller regions, and the mechanism which deforms the current density is generally known as a proximity effect. So here the increase in the effective resistance of the wire is also visible and is dependent on the value of the operational frequency. Here you can see some representation of the effect of the current loop if we consider some direction of the flow of the current. So you can see how the areas are exposed to a higher current density. So here you can see that the effective or the highest current density is located on the sides of the conductors. And the situation is being worse if we consider also the increase of the switching frequency. So here we have analyzed some operational frequencies. The most interesting are from these 21 kilohertz above, because these frequencies are being used in the switched mode power supplies, so in the commercially used or industrially used switched mode power supplies. Here is also the analysis of 1 megahertz, because the gallium nitride technology enables to design such converters for high frequency operation. And the conductor which is considered is a standard 24 AVG conductor. So you can see how the current loop is affecting, and it is important to consider this effect in the design of the high frequency transformers and inductors. So not only the skin effect is important, but also a current loop because of this relationship. And then there we also made some analysis related to the value of the diameter of the wire. So there is also a dependency on the wire diameter, how the normalized resistance is being changed, and also for a selected diameter of the wire, we have the evaluation of the frequency dependency on the normalized resistance. And finally, we have provided some procedure how to calculate the area, this area, which is the effective area for the conduction of the current. And there is some strategy how to provide this calculation and how to find, let's say, the skin depth also if the current loop effect is being considered. So this procedure is very well described in the paper, and also it is explained. So you can find the values of these important parameters. Also, they are useful if you are going to provide the finite element analysis. So thank you very much for your attention.
Okay, thank you, Professor, for a very interesting paper. Now the paper is open for discussion. Any question from audience? Any question from audience? May I have some remarks? You know, the problem is a key problem, since not only in power transformers, but also, as you already mentioned, in a high frequency any devices.
Yes.
Since nowadays, due to the application of technology, digital technology, that's this very high frequency is being involved in all practical equipment. Therefore, we found increased losses, not only power transformers, but any other things. Therefore, your conclusions are very important, and probably we would have to change the cross section or even the shape of the conductor which is used for these devices. You know, am I right?
Yes,
okay.
yes.
That's very interesting things.
Yes.
Any question? Okay, if not, thank you very much, Professor, for a very interesting paper. Thank you very much. And now we are going to another presentation. And another presentation will be given by the colleagues from Turkey. And that will be estimating the distributed generation unit sizing and its effect on distribution system when using machine learning methods. Is given by Mikhail Purli. I'm sorry, that's what. How do you spell your name? Purli? Purli. I'm sorry. I'm very sorry. Belgian Emre Turkey, and they are from Department of Electrical Engineering, Istanbul Technical University, Faculty of Electrical and Electronic Engineering. Okay, are you professor? Yeah, doctor. I'm sorry, just.
No, I am PhD candidate and research assistant.
Okay, Mikhail, please go ahead. You have 15 minutes for your presentation. Fine. Please go ahead.
Thank you. Hello, everyone. I am Mikhail Purli from Turkey. I am a research assistant and PhD candidate in Department of Electrical Engineering at Istanbul Technical University. I am going to talk about prediction of distributed generation unit size and its effects. My presentation consists of 6 parts. The first part is the introduction of this study. The second part is about the methods used in this study. In the third part, I am going to explain how estimation error and performance evaluation are performed. The fifth part introduces the data and programs used in our study. The next part contains the result of analysis and discussion. And finally, the presentation will be completed with the conclusion section. Okay. The aim of this study is to estimate the sizing of distributed generation unit sizing of distribution generation units and their effects on the distribution system or grid. The small powerful generating units integrated close to consumption areas to meet the increase in energy demand and called as distributed generation and are briefly referred to as DG. DG integration has various benefits such as reducing system losses, improving the voltage profile, reducing pollutant emissions, and increasing system reliability. But incorrect DG allocation doesn't benefit. On the contrary, it hurts the power system. To provide effective DG allocation, various optimization methods have been reported in the literature. In the literature, many studies on DG settings have been carried out with analytical and heuristic methods such as genetic algorithm, particle swarm optimization, differential evaluation, artificial bee colony, nonlinear programming, while optimization algorithm, bacterial for-all optimization, and colony optimization, J algorithm, cookie search algorithm, tabu search algorithm, and harmony search algorithm. All these methods have been applied to IEEE test system or specific region power system of various countries of the world. And many forecasting methods have been used to make forecasts such as load forecasting and wind speed forecasting related to the power system. However, there are no studies on estimation of DG size and its effects. Our contribution is the estimation of DG size, network active losses, reactive losses, and minimum bus voltages without of difficult time-consuming power flow calculations. And used methods. In this study, machine learning methods such as linear regression, artificial neural networks, support vector regression, k-nearest neighbor, and decision tree are proposed for the prediction process. And next section, rand performance evaluation. And R-squared error-based analysis is used to predict the performance of reliability of the model. The R-squared error is calculated as in equation 1. Here, Ri is the real value, Pi is the prediction value, and Mi is the mean of actual values, and N is the number of samples in the test data. R squared takes value between 0 and 1, and is decided to be close to 1. The ratio between absolute prediction errors and the real values is defined as mean absolute percentage error, briefly MAPE. It is used to measure the performance of prediction and evaluate the results. MAPE is calculated as in equation 2. You can see. Okay. Data collection and used programs. Firstly, about data collection. In this study, a data consisting of a normalized load variation, DG power injection, and DG location, active power losses, reactive power losses, and minimum bus bar voltages have been used for 3 test systems, IEEE 12 bus, 33 bus, and 69 bus distribution system. The normalized load variation for seasonal load profile is shown in this figure. These all data are provided on the GitHub repository. And used programs. Developed prediction models in this study have been created VEICA, which consists of the initial of Veicata environment for knowledge analysis. It is a field data mining software that includes many machine learning algorithms. While making predictions, 75% the data have been used for training and 25% data for testing. And VEICA algorithms, linear regression for linear regression and multi-layer perceptron, artificial neural network, SMOREG algorithm for support vector regression, IBK algorithm for k-nearest neighbor, and M5P algorithm for decision tree have been selected as a classifier in VEICA. Then the parameters of each algorithm have been optimized to perform the prediction. And the running of all forecast graphs and estimation performance analysis, such as ReShukar and RShukar and MAPE, are created by MATLAB. And a result of analysis and discussion, various estimations have been made and evaluated by creating 5 case studies. In case 1, DG sizing is estimated using a normalized load variation. The 5 estimation methods, linear regression, artificial neural network, k-nearest neighbor, and decision tree, are applied for 33 bus and 69 bus distribution test system. You can see the comparison of DG size prediction with actual values in the graphs. And the one for 33 bus and right one is for 79 bus. And looking at the performance evaluation table, it seems that the estimates made with all proposed methods are very close to the real values, and the best result obtained by support vector regression of about 0.9 and 0.7. And in case 2, the input is normalized load volume and output is active power losses. And this graph for 33 bus and other graph is for 69 bus test systems. The prediction made with the other 4 methods except linear regression are very successful. But linear regressions gives high MAPE and low ReShukar values. The best results are obtained by support vector regressions of 0.2%. In case 3, the input is normalized load volume and output is reactive power loss. Result of these cases are the same case in case 2. In case 2, active power losses was predicted. And in case 4, the normalized load volume and the output is minimum voltage, or in other words, worst bus bar voltages. And these graphs for 33 bus and other graphs for 69 bus. And you can see from the table, all methods have ensured successful predictions made of nearly 0%, and the best one is CVR, support vector regression. And finally, case 5, the output is active power losses, and there are 3 inputs such as normalized load variation, DG sizing, and DG location. Linear regression is not used in this case because it gives large errors well above the acceptable limits. Since the graph contains big data, they are enlarged in a certain range at the bottom of figures to make it look comfortable. This one is for 12 bus, and right one is 33 bus, and bottom is 69 bus. And the best results are obtained by k-nearest neighbor of nearly 1.4 and 0.4. And this column chart compares the best results in each case. In case 4, since there is a linear relationship between the input data and output variables, the output variables have estimate with MAP of nearly 0%, while the best results have obtained with support vector regression blue ones. Support vector regression in case 1 to 4 with single input variable, and the best results have obtained with k nearest neighbor for case 5 with multiple input variables estimation. And finally, conclusions. This novel method based on estimation is proposed to determine the size of DG and its effects on the network without using coercive and time-consuming load flow techniques and machine learning algorithms such as linear regression, artificial neural network, support vector regression, k-nearest neighbor, and decision tree have been used for the estimation process and have been applied to well-known test systems such as IEEE 12 bus, 33 bus, and 69 bus distribution systems. And the accuracy of the proposed estimation methods has been verified with R-squared and mean absolute percentage error. And the result of analysis show that the proposed approach can be effective, flexible, and applicable to determine DG size and its effect on the distribution system. And the study is the first about the DG estimation, and in the future, it can be improved. Thank you for your attention.
Okay, Mikhail, for a very interesting paper. You know, now the paper is open for discussion. Any question from audience? If I have some digression about that, you have found that depending on situation, depending on demands, you have to use different methods. And the best one, if I'm not wrong, you have found is SVR and KNN. Therefore, could you do it combined methods and combining the calculating both or one SVR and KNN? Combining both, is it possible to do that and then make a compromise as a conclusions, or no? Since it depends what are you calculating on, you know, if about the active power is a KNN, if about the voltage is a AVR, okay?
I didn't do it, but it's a good idea. It can try the hybrid models.
Okay, I think so. That will be okay. Thank you very much. Any more questions? If not, Mikhail, thank you very much for your very interesting presentation. Now we are moving to another paper. It's a paper given by the people from the Pakistan. And the title is Reactive Power Support and Radial Distribution Network Using Mine Blast Algorithm. Is prepared by the Mohsin Shahzad, Qazi Shafiullah, Bassem Akram, Muhammad Arif, and Barak Ullah, and will be presented by Mohsin Shahzad. Mohsin?
Yeah, do you hear me?
Okay, that's good. Okay, Dr. Mohsin Shahzad will present the paper on he is from Department of Electrical and Computer Engineering, but I'm not wrong, University Islamabad, is right? In Pakistan. Okay, yep. Therefore, please go ahead, you are free. You have 15 minutes for presentation.
Share screen. This one. Can you see my screen now?
Yes, sure, go ahead.
Yeah, thank you very much, Professor Madzinski, for inviting me to the presentation. Today, my talk is about the reactive power compensation and reactive power support in radial distribution system. And we have been using a novel algorithm, that is mind blast algorithm, for optimizing the problem. So the introduction of the problem is that our objective is to reduce the power losses in the distribution networks, because the power distribution networks are actually they have increased losses due to increased demand, and the power in conventional system is transferring from over the long distances, and the power losses in the power distribution networks is about 13% of the total losses of whole power system. So we should work hard in order to reduce these losses. And the problem in distribution system is that they have a higher amount of reactive power demand. So if we can compensate the reactive power locally, then the power flow from the main grid would be significantly reduced. So in order to provide the reactive power support, we have a number of techniques, and here is a brief overview of those techniques. For example, the synchronous condensers are very commonly used. These are mature techniques, and they are used very commonly in conventional power system. However, they have a small drawback of because they cannot be rapidly modified and according to the load transitions. The second and relatively newer technique is that we can optimally place distributed generations, as my previous colleague from Turkey presented, that this will help in increasing the green energy harvesting and reducing the power profile. However, this also requires plenty of planning, and the amount of money that is needed in order to install distributed generation is also higher. And they also have some challenges with respect to managing those distributed generation, because the distribution systems are not designed for bidirectional power flows. And secondly, the next technology that we have is flexible AC transmission systems. These are also power electronic based devices, and these can be mounted on the transmission systems, as well as the distribution FETs are also now in the market. They provide additional damping to the system and provide some more flexibility and additional capacity in the power distribution system. However, they are also installing distribution FETs is also challenging because of the space availability and challenges like that. So the capacitor placement, which is also a very common and mature technique, can be used in for providing the reactive power support, and it is more reliable and considerable economical. It can help in improving the power factor of the system, and then can help in improvement in voltage profile and mitigating the voltage fluctuations. So in this work, we are primarily focusing on placement of the capacitors optimally in the radial distribution systems. The reactive power support with the capacitors can be modeled in for many different optimization variables. Different researchers have thoroughly discussed and studied this problem, and different type of algorithms like numerical programming, analytical methods, and artificial intelligence methods have been used. So in this work, what we have done and our contribution are that we have attempted to reduce the total annual cost of installation and operation of the capacitors. We have tried to place the capacitors in the radial distribution system in such a way that the annual operation cost, as well as the cost of installation of these capacitor banks, should be reduced, and also the active power losses and reactive power losses are reduced, voltage profile is improved, and voltage stability of the network is improved significantly at the end of this method. So the problem formulation is primary objective is to reduce the power losses, and this is because we are primarily concerned with the reactive power also. So both the reactive and active components of the impedance of the line are considered here. So in order to minimize the loss, we have to keep these conditions, the constraints in the mind that voltage should not be touching the minimum or maximum limits, and the reactive power demand or the complex power demand of the network must be met, and the lines must not be overloaded with the current. So the cost has been calculated using this relation shown here. And this different variables are taken from the literature, and these are summarized in this table. And the voltage stability index can be seen in this diagram of for a simple network in with two nodes like M1 and M2, where the current is flowing from M1 to M2, and the impedance of the line is R plus JX, and the voltage at bus 1 is VM1, and voltage at bus 2 is VM2. It can be shown like this one. And in our method, what we have done is we have categorized these system buses before the reactive power compensation according to their voltage stability index, and then we have taken the top 50% of those buses in order to reduce the search space for mind blast algorithm. After this voltage stability index, we have implemented the mind blast algorithm. Just a moment, these two slides. So after this voltage stability, we have optimized, after shortlisting the locations for optimal placement with voltage stability index, we have optimized for their sizes and final selection of the location based on the mind blast algorithm. And the steps involved in mind blast algorithm are explained in these two slides. And in this method, what we do is it is very analogous to the mines in the wars and like that. And when some mine blast, some shrapnel pieces spread in the nearby vicinity of that blast location, and it is likely that some of the shrapnel pieces hit another mine nearby, and then they explode, and there is another explosion and blast of the mine, and this chain continues until the location for the optimal until the maximum explosions and maximum disaster can be achieved. And this is translated in our research that we think that for the first location we have chosen in the guess estimates, this will try to reduce the losses in the network, and line flows solutions are those which have the smallest distance from the previous location. And in this way, the optimal solution is found. And these are the complete set of steps. I have given it in our article also. So due to time constraint, I do not go into much detail of them. And here I am trying to present my results. In this work, we have taken two IEEE standard radial networks. One is 33 node network and another is 69 node network. And we have tried to place the capacitors in these networks using the method I have just explained. And I have compared my results with other contemporary methods available in the literature. These methods are a strawberry plant propagation algorithm, genetic moth swarm algorithm, GMSA, and flower pollination algorithm, FPA. These methods Out of these methods, I have implemented SPPA method myself and along with my colleagues, and the other two, GMSA and FPA, are not implemented by us. We have just taken the results of the other authors and researchers. So what we have seen is the results for 33 node network. It shows about the power loss, active and reactive power losses in the network. Before compensation, the power losses at branch number 5, for example, were very high, and in active power losses on branch number 2 were very high, and but after the reactive power compensation with our method, the losses have been significantly reduced. And the second important parameter that we have mentioned here is about the voltage profile. In this network, 33 node network, the voltage profile has also improved significantly, as you can see here on bus number 18. The voltage was very low. It was about 0.9 per unit, but it has significantly improved with our method to 0.945 and 0.95 and so on. Similarly, this table summarizes the results in terms of losses and the voltage profiles and the annual cost. The results for power loss and active and reactive power losses have already been shown. Here, the important result is about the annual cost. With our method, the annual cost is 82,000 approximately in dollars. Whereas with SPPA it was 88,000, and with FPA and other methods, it is also a bit higher on the a bit higher side. So we have this amount of saving with respect to the base case. This is $27,000 annual saving for this small system. And the voltage quality index, which is also another parameter to quantify the health of the voltage health of the system, is about 94%, which is on the better side than FPA and GMSA. SPPA has shown a slightly better results, as we have already seen in our previous slide from here too. For 69 node network, I have similar pattern of presenting our results, and these results are also summarized in this table. Due to time constraint, I have to sum up it here. The annual saving is approximately $29,000, and the voltage quality index is about 93%, which is somewhat higher than the base case and comparable to the other method. However, we do have a better loss reduction ratio with lesser amount of injected VARs, because the VARs injected in our method are 1,780, whereas with other methods, the injected VARs are on the higher side. So finally, the conclusion of our work is that the optimal capacitor placement has significant improvement in loss reduction. The novel mine blast algorithm has produced better results. The voltage stability index is used, and voltage quality of the system is improved. The losses have been reduced in 33 node network up to 34% and 33%, whereas in 69 node network, active and reactive losses are reduced up to 34 and 32%. The voltage quality is also has improved, and it is 93% and 94% for both of the networks. The annual saving is about 24.8% and 24.5% for 33 node network and 69 node networks respectively. I thank you all for your time, and I welcome any suggestions and questions. Thank you very much.
Thank you very much, Dr. Sazar, for your very interesting paper. Now, with this, please, the paper is open for discussion. Any question from audience? I would like to say that you are considering the only reactive reactive power, but however, probably in the future, you will have to take into account inductive power, since nowadays, due to digital modulation and pulse switching, we have found that tremendously increased not the capacitive reactive power, but inductive reactive power. Therefore, the problem of compensation becomes totally different, since if you use too much capacitors, you will get overcompensation. It's also, but it's another problem. Okay.
Yeah, exactly.
Yeah. Okay. Any questions? No, thank you very much. Therefore, we will go to the last paper.
Thank you very much.
Last paper. Thank you for a very interesting presentation. Last paper is given by the title is a comprehensive design and optimization of brushless direct current motor for the desired operating conditions. It will is made by the people from Turkey, from Ostur Tosun, Nesibe Fusun Ayman Schertlerer, and Gökhan Yalcin. And presenter will be Mr. Schertlerer. Okay, are you here? Nobody is here?
I am here. I am here.
Oh, it's you.
I will.
Okay, I'm so sorry. Are you professor or doctor?
Professor.
Professor. Sorry, professor. Therefore, please go ahead. Dr. Professor Schertlerer will have a speech on comprehensive design and optimization of brushless direct current motor for the desired operating condition. Please go ahead, professor.
Thank you very much. Thank you very much for introduction. As Professor Bogdan Mikandezic, my title is Comprehensive Design and Optimization of BLDC Motor for the Desired Operating Conditions. Now
we see you.
Yeah. Okay. Can you see my?
Okay, now we can see. Please go ahead. Please go ahead, Professor.
Okay, thank you very much. The outline of my paper goes like this. First, introduction. It consists BLDC motor advantages and design specification, and later theoretical and experimental discussion on motor design, and consists BLDC motor design parameters and mathematical equation.
One questions. In just a moment, I will display these questions on the screen. You will have the time to write it. I think that within 1 hour will be okay, but if somebody will not do extended, please. Okay. Any question? Okay.
No question, Professor.
Yeah. Okay. Therefore, yeah. Okay. You go ahead. Therefore, I will display just in a moment.
I'm sorry. Can I carry on my presentation?
Please go ahead. Okay.
Oh, okay. Yeah. Okay, I carry on my presentation. And second subject of our outline, theoretical and experimental discussion on motor design, which consists of BLDC motor design parameters and mathematical equation, analysis application, experimental and simulation results. And I'm finishing my presentation, conclusion, and future works. In introduction, I would say that first I start my presentation advantages of the BLDC motor. So longer operating life, low noise and vibration, high efficiency, high speed ranges, high torque, high dynamic response are main advantages of BLDC motor. These advantages, combined with the easy controllability facilities that makes them very attractive for electrical vehicle application. Recent advances in design software packages makes this kind of motors very preferable, both in industry and in research area. Especially improvement in design software packages have widened the limits of the BLDC motor performance. One of most used and most popular software packages, design software packages about that is ANSYS Maxwell, which we have used this software in our study. So this paper, briefly, I will say that this paper describes the comprehensive design equation which are based on the actual BLDC motor rated values or parameters. Design motor have been analyzed by using Maxwell 2D software. Motor size have been revised with performance enhancement efforts, and also parametric analysis have been realized in these studies. So, in this slide, you see our structure, 3D structure of our studied BLDC motor on the left side. On the right side of the slide, you see the motor template values and rated power, rated voltage, reference speed or rated speed, we can say, rotor outer diameters, number of slots, rated current, number of pulls, and efficiency. So this template is important because we implement all those rated values into ANSYS Maxwell simulation design. So using all the equation design, we first studied the design equation analytically. We have all used the equation as you see on this slide. All those equation, and first equation is very important actually, because you get the torque value from there. And this is the most important things for the electrical motors. And we have used all those equations, and we have find out all those. We have verified all those equation results with the ANSYS motor design analysis, and we have got the same results. And we have also used, as I said before, actual motor parameters to have the design results. So on this slide, you see the dimensions of our analyzed or studied BLDC motor: rotor diameter, axial length, slot length, slot height, stator outer diameter, minimum air gap length, magneticness, stator inner diameter, slot top width, slot bottom width, slot pitch. So we have all real these motor parameters and dimensions. So after analyzing the results, we have had the motor simulation results. So you see on the top of the left side of the slide, and the analysis results on the bottom of the left side, efficiency versus speed graph, a moving torque time graph, and flux density. But the important information here, we have found the table on the left side, on the top of the slide. We got this very close simulation results with the actual rotor rated parameters. the error was less than 0.3%. And so the average or input current you see 15.94 and the output power 670, efficiency 87.5. So these were the actual values. See here, we nearly as close as the values we have found in our analysis results. So we, after found the closest results, we studied the optimization studies, and you see here we taking care of all the parameters of the BLDC motor. That's why we named our study comprehensive design. So stator auto diameter, axial length, air gap length, rated power, rated speed, and DC voltage are kept constant in this study, and the other parameters we try to optimize and try to get the better efficiency, better speed, better torque, and better loss in this study. So for this, firstly, this total inner diameter is increased by 40 millimeter. The inner and outer diameter of the rotor slot pitch increases, of course. So also in table 3 and 4, as you see, magnet thickness are studied for in constraints and in limitation for 4 millimeter, 5 millimeter, and 6 millimeter, and we have all studied these parameters for efficiency, rated torque, rated speed, holding torque, air gap plus the density, and you see all the studied results here. And also effect of skill we have studied, and all those studies we have got that they we should have magnet thickness of 5 millimeter. It was 4 millimeter in simulation. Skill ratio 0.5. Magnet type neodymium ferrite 35. Steel type steel 1008, and embrace 0.5. The slot edge, slot top wide, and slot bottom wide are reduced without changing the are reduced actually first without changing the conductor loss, but this time we passed the limitation, then we changed the number of conductors per slope. We reduced the number of conductors, and we just considering all the constraints and limitations. We try to find the efficient and less loss, less power loss. We try to get the less power loss actually. So in this slide, BIDC motor optimization studies you see. As I said in previous slides, we have studied on effect of magnet type, effect of still type and effect of embrace. All those effects are studied in detail and found these results. And also, you see the optimized flux density and non-optimized flux density, and vector potential. Here is the optimized was better than the non-optimized parameters. And as I said, these are all dimension and motor parameters are taken from the actual results. You see the efficiency, speed graph, and experimental simulation and optimized torque speed curves you see here, and experimental photograph as you see here. So at the end of the study, we have realized that the experimental rated torque 5.9 nm, simulated 5.0 nm, optimized 5.5 milli, and total loss are found 98 watt, and the least total loss is seen in optimized results. And as a summary, magnet thickness, secure, magnet type, secure type, and various effects, you see the effects to efficiency and torque you see here. We summarize this. So, as I said before, magnet thickness was examined here, and the most suitable magnet thickness are found, or I should say, determined 5 millimeter, and secure factor is studied, and it was determined as 0.5, and magnet type is not determined, neodymium ferric 35 magnets, because of the Pogin torque is important, as I represented in previous slides. And steel type determined steel 1080. Embrace effect was determined 0.7. Slow tape has been reduced in limitation. Number of conductors were introduced too. And mainly the rotors are to diameters, and decreasing the slow type in height within the limitation is determined 50 and 54 millimeter, 11 and 14 millimeter. Affect the efficiency and torque values of BLDC motor positively. So as a conclusion, we have studied here really a very comprehensive design using ANSYS Maxwell tools and Maxwell 2D analysis, making multi-parameter optimizing with multi-parameter of BLDC motor. So at the end, BLDC, we increase the BLDC motor in the same value from 78.2% to 90.9% actually. So in the future studies, we can say that the volume of the BLDC motor can be decreased with the keeping constant efficiency same and speed same and torque same, or the other maybe electromagnetic analysis maybe carried out to improve motor performance. Yeah, that's all I can say in our study. Thank you for your attention. If any questions, please ask. I can't hear you, Professor Bodan. I can't hear you.
Okay.
Professor,
do we have any questions?
Microphone is closed.
Now can you hear me?
Oh, yes, yes.
Okay, fine. I don't know, something happened and the microphone was out. Nice work, I would say. That's really nice work, particularly that you did not only calculation, but also you have checked some in some area these results. May I have a question, since you use different magnetic materials, did you base in your simulation on the measured magnetic loops, or just use middle magnetic line with adding with some resistive losses?
Just use actually magnetic lines.
Okay.
No
measure.
further. Yeah.
You don't measure the material.
Yeah. No.
Okay.
No,
Okay.
we haven't measured anything.
Understandable. It's a really nice work and hard work.
Thank you very much.
Okay. That's any question from audience? Any question from audience? Now, thank you very much. Thank you very much for a very interesting presentation.
Thank you very much.
Thank you. I would like to thank all the presenters for the very nice papers, for well-prepared presentations. Thank you for audience being here. However, not too many questions. I don't know, usually when we have online presentation, not too many questions. Thank you very much. And now, Darius, do you want have some questions? Do you have some good questions?
Maybe not questions, just to say thank you to Mr. Chairman and to all the presenters. I hope to meet you next time somewhere in Lithuania.
Okay, I
hope you will be able to travel.
Yeah, I hope so. I hope so. Therefore, thank you very much. And now we will have a break till 12:30. Okay, thank you. Thank you and bye-bye.
Thank you.
Bye-bye. Thank you.
Bye.
You got my screen?
Yes.
Okay. Good afternoon to you all. Sorry for I thought there is somebody in front of me. That's why. My topic is convolutional neural network and fuzzy logic based I don't know about their system.
Socrates, I'm sorry, but it is not your turn.
Sorry?
Actually, you are right, because there are at least two.
I thought there is somebody in front of me.
If I can see correctly.
Is it my turn or not?
Let me check, but
not yet. But session
there
is
is
correct.
at least one in front of you before you. Let me check the program. Yes, not yet.
Jaromir, your voice is very strange. I mean,
The
it's
session is
something
correct.
to
It's
do
session
with the internet
8A,
connection.
right? And
we can't hear you.
Are you talking with me or?
No, I'm afraid it's concerning me. So just a second, please.
Okay. I can stop sharing if you like my screen.
Okay. Maybe we will wait for 1 or 2 minutes until chair will back. Okay.
No problem.
Okay.
Now it's better.
I'll be back. So once again, apologies for the complications. So I have some technical issues, sorry. But basically now I think everything is working well. And since the time has come, we are about to start this afternoon session. So I'd like to welcome all of you here, lady and gentlemen, if I count correctly in the list of participants. There should be at least one lady with us. And we have today a mixture of different interesting topics that you can see in the program. What I'm going to do, and I'd like to do this usually because it's often a problem for a chair to read the names of all presenters correctly. So I'm well able to read the names of those participants who are of Slavic origin, but I sincerely apologize to colleagues from Turkey and other countries that I could mutilate your names. So I'd like to ask you personally to introduce yourself so that it's nothing embarrassing for anybody. We have about 15 minutes per presentation, so let me start right on with the first one, not to take your time and to give some more time for discussion. The first presentation shall be ready from Serbia by, I'm not sure, Istvan, how do you pronounce yourself, from University in Novi Sad, if I'm right. And it's about IP device provisioning and abstraction in IoT solutions for MQTT-based protocol. So that's basically about networking, right? And about the Internet of Things. So please, it's your turn. The floor is yours.
Okay, thank you very much. Actually, you pronounced my name perfectly. So it's Istvan. So you made it right first time. So let me share my screen. Please let me know if you see my screen. Yeah, perfect. So first of all, I would like to thank you for being here. Special thanks to Darius for his great support, and also thanks to the chair for the great introduction. Let me describe you and explain you what we have done in the past and what we have achieved and what are the results we are really proud of. My name is Istvan Pap. I'm coming from the University of Technical Sciences from Novi Sad, Serbia. And with my colleagues, Roman Pavlovic and lady colleague, Maria Antic, we have developed WISE, which is an MQTT-based protocol for IP device provisioning and abstraction in IoT solutions. What was the motivation for such a work? What we have found throughout working for several years in the IoT domain is that the ecosystem is really, really heterogeneous. So there is no generic solution. There are some partial and niche solutions, which makes interoperability really difficult. Many of the IoT stacks are based on TCP/IP, which at first glance it sounds kind of a standard, but all the implementations are specialized for addressing specific needs, so that you have an IoT solution for monitoring or power control or different applications, but they're not able to communicate with each other. The reason for that is that the semantic layer, although the networking layer is similar, the semantic layer is totally different, and the entire IoT domain is really fragmented. That is quite frustrating both for the user, because the end users, customers, they cannot just buy devices and make them work together. But on the other hand, it's quite difficult for business participants, for vendors or service providers, because the ability to combine different solutions is really minimal. Some solutions are to introduce protocol bridges that would allow to solve the differences, but in that case, you know, you have a huge gap in user experience. For example, in the smart home domain, if you buy smart things from Samsung and Philips Hue from Philips, you might make them work together, but you need a certain technical knowledge to do that. To overcome these constraints, in this paper, we describe a new protocol which runs on top of MQTT, which is generic, which is scalable and covers the entire life cycle of all of the connected devices. Of course, there are some existing solutions as of today, but as I said, they're really targeting some specific applications and cannot work together. There are some protocols that are widely used in home automation. They're like ZigBee, Z-Wave, BLE, or even DECT ULE, which are again targeting smart homes. They specify what the messages means, the semantics, and yet they cannot work together. On the other hand, they have some great features like mesh networking. They're really good for low power and battery powered devices, although they have low bandwidth, but that fits quite well the home automation usage. Further, the device discovery and advertisement is as of today provided by UPnP, which is again a protocol used by TCP/IP networks, but UPnP is really heavy on resources, so it's not really a good fit for low power devices, and microcontrollers like ZigBee, Z-Wave, and BLE are. MQTT and CoAP are kind of candidates for such a universal IoT protocol, but again, they're only defining the network layer and the communication layer. They are not imposing any hints on what actually the data that they carry means. So there is no semantics there. Similar to them, there are some additional protocols like 6LoWPAN, IPv6 thread, which are getting closer to the TCP/IP world and the protocols I mentioned in terms of home automation like ZigBee, Z-Wave, and so on. And they're really simple, suitable for embedded devices. But again, the semantics is missing. Of course, we are not the only one who saw this gap and try to mitigate the lack of kind of a standard. So in 2019, big companies like Google, Amazon, the ZigBee Alliance, I think it's even Apple is in that consortium. They started something called CHIP. It's a connected home IP initiative that aims something similar what we do. The idea was started late 2019, like 1.5 years ago. Unfortunately, that's way still in the definition phase. So some devices using chip might come in next year. But again, although chip defines the communication and part of the semantics, but some important items from the device usage life cycle, like association and commissioning, is still missing. As a response to that, we propose our own protocol. We call it WISE, which has the following characteristics. It's quite complete. It covers all usability aspects of the connected device, from association, from communication, commissioning. So each detail is built into the protocol. It is quite abstract and generic. It allows to decouple the communication from related services. That allows that based on WISE, you can just assume the devices are there and you can build new services on top without going into the details, whether it's a ZigBee or IP or any other communication. It is lightweight. It can run on microcontrollers. It can run on servers as well. I will explain that or illustrate that later on. Complexity-wise, it's similar to ZigBee or BLE, which you know it's quite low requirements on resources. What we saw that IoT is a really fast-moving industry, so the protocol has to be future-proof, so it needs to be extendable. And by using some generic models, it will allow further and new devices to be integrated and built in, but it will be always backward compatible because we learned that in IoT, the existing installations are slightly different than in consumer electronics. We are not talking about a year or 2 or 3 years. We are talking about 5 years or 10 years of utilization. IoT systems are huge, scalable. That's also built into the protocol. It is prepared to work with some new technologies like IPv6, NB-IoT, and 5G. It is considering battery-powered devices. As of today, many sensors around us are battery-powered. Of course, it needs to be secure. So security is built into the every aspect, from the commissioning and association up to the data transmission to the cloud. And of course, there are some related functions like device discovery that makes configuration easier, commissioning, field updates, backup, restore, diagnostics, and so on. There was another premise of us, which is usage of open standards. As of today, in order to have a successful initiative, you need to rely on open standards to be transparent as much as possible, and that would be, one prerequisite to achieve wide adoption. On the right side, I hope you will see my pen. Yeah, great. So on the right side, I noted here kind of a protocol stack, how we built up WISE. So it's based on TCP/IP and UDP, of course, and the key higher level protocols are MQTT, which is, as of today, quite a lot used in IoT, HTTP for certain initial setup steps, and SSDP for discovery. I will give some more details later on about that. This is the overall architecture that is possible to achieve with WISE. We introduced some terms like WISE Hub. This is a device that can be connected to many different communication technologies like ZigBee or Z-Wave or even BLE, WISE, Modbus, whatever. And of course, it supports WISE devices as well. It can talk to them, configure them, and pass on the data from WISE devices to the cloud for further processing and services. That's possible to be done in kind of a local area, a home, one installation, a factory, or a field. But that works quite well also when those WISE devices are remote. That means that WISE is not bound to a local area. It can spread across a wide area. That would mean, for example, that you can have a device somewhere in the field, and yet through WISE protocol, it would appear as part of this installation. Further, we can cascade those hubs to build up really complex solutions with many smart devices. So one typical use case, if I need to illustrate it at home level, if you would have a smart home within your house, and then you have a meteo station somewhere, I don't know, like 100 meters from your home without the reach of Wi-Fi. And in that case, WISE will still bridge the gap.
So we have two minutes left.
Sorry?
Some 2 minutes more.
Oh, then I need to speed up. Thank you. The other option would be to have the hub somewhere in the cloud, and WISE is also capable to cover that. So all those WISE devices can connect to a virtual hub somewhere residing in the cloud. So the typical use case would be smart cities. I will skip maybe some details about the implementation. So we are using JSON for as a message format. Then all the necessary information is put there, so we can use and utilize all the publish subscribe mechanism that MQTT provides. The communication can be both asynchronous and synchronous. And of course, we are using the topic structure provided by MQTT, and the flexibility is built in throughout the topics, so we can define logical entities and access credentials. On the other hand, on the right side, we are using something we call a device model, where a device is abstracted by services and properties. I think I will skip some steps related to the some implementation details. I think this is an interesting point, that each device is comprised from different services and related properties. And actually this allowed us to combine and to create any device we want. And this is what makes the solution future-proof. So as of today, we support many and built in many services and properties, starting from diagnostics and firmware update like temperature and so on. So by these atomic pieces, we can assemble a device which will be handled by the system and WISE protocol transparently without any additional processing. The implementation was done on some Linux devices like Raspberry Pi. The hub, actually this concentrator, the hub runs on a Linux, and it's a C++ software, while the actual devices are running on microcontrollers. So the WISE device is a much simpler, much cheaper and less complex platform. And based on this, we built several examples. We started with the light bulb, then extended to smart meter, and the latest one is a smart speaker. And all these devices are nicely communicating through the WISE hub. Either it's a physical one or virtual one to the cloud. And typical usage is like control, monitoring, automation. That's all supported. This is a picture of a test setup. I will keep it short. We did functional performance and stress tests to test the device and the hub. And we found that all the operations are handled quickly, so it's efficient. As you can see, the message processing time is like 14 milliseconds. The association is half a second, which is even faster than with ZigBee and Z-Wave. And of course, function-wise, we were able to have really good user experience and high level of interactivity. So just to summarize the work, so the motivation was to come up with a generic protocol that will solve all the hurdles and issues we were facing in the past 5 years related to the IoT protocols. We came up with the concept and we experimentally proved it and tested it on different platforms. And I'm happy to say that we already have some early adopters from the industry, both for the smart city and the smart devices domain. And I really hope that this WISE will be attractive enough to other vendors as well, so that one day we can make standard out of it. Thanks your 4 times. Sorry for being late.
Thank you for your presentation. I think it's interesting. And I guess we can afford some 2 questions. Okay. Please, gentlemen, if there is a question, just tell us or raise your hand. I'd like to ask personally, because this is something also interesting for myself, the documentation about your, let's say, research and project is available somewhere on GitHub or by your university website, or through which resource? Because I'd like to share this with my colleagues, and perhaps there might be a fruitful cooperation for the future.
So it's not publicly available. Actually, so far what he has shared is with some potential partners is the description of the WISE protocol and the system. So we have some documentation available. So we can follow up after I can leave my credentials. We can follow up to discuss and share some further information.
Okay, thank you. Any other questions, please, gentlemen? If not, then thank you very much. Please stop sharing your screen at this moment. And I'd like to invite the second speaker. And this time I'd like you to introduce yourself. Really, we are now jumping from Internet of Things to medical technologies and to healthcare. And the second paper is about fuzzy logic and neural networks in the services of melanoma diagnosis. So please, Fikret, do I read it correctly? It's your turn, please.
Thank you. Thank you. I got it. Thank you all. Thanks to Darius and Chair for their contribution to this conference and making it available for all of us. My topic is, as you said, it's the medical application. We try to figure out a hybrid melanoma diagnosis system. The early detection of melanoma is a very critical issue. The first aim was actually to define what is the early detection, to define if it's possible, but through the literature we found that it's very difficult to define, because there is a lot information there, and to make a concrete and standard definition is not possible, nearly is not possible. That's why we actually evolved our intention to a hybrid mechanism, if it's possible, based on either hardware design or algorithmic based approaches. Due to that, we saw that the computer-aided diagnosis systems are already there, and there must be something new. Then we found that these neural network machine learning based new systems, CNN and deep learning, is quite powerful candidates to attack this issue. That's why we actually concentrated on different algorithms used or networks used within the CNN and deep learning, because these new techniques, especially CNN and deep learning, make it possible to detect as early as possible with the conventional methods, and then we saw that although CNN and deep learning methods are quite powerful, but there is another issue standing there and waiting for us. It was the medical grade data, to find medical grade data and big data. That was another issue, another big issue within the system.
Sorry for the interruption. Maybe it would be better if you switch your PowerPoint to presentation mode by pressing.
Okay, well, okay. I just want to gain time. Okay, you are right. So we just went through the new methods, and we tried to find whether we could be able to by using these new techniques, whether it will be possible to get new information which is hidden within the images which are available worldwide. You can see on the internet everywhere, but to find out the information, the required information related to the melanoma diagnosis is not easy, because there is a huge scientific research within this area, and it's very difficult to get a new part of information from it. So what we concentrated on the pixels and their contribution to the color and the shape of the images through CNN. To do that, we tried to measure the pixel size and pixel values, and their relationship with their neighbors. What the neighboring pixels are contributing to the, let's say, central pixels and to other consecutive pixels. That's why we found a new, actually we designed a new architecture. I hope you can follow my my computer. Now I'm pointing to the normal image. We put this image to four pre-processing techniques. We name them as compact M matrix, distance vector, pixel intensity matrix, and covariance matrix. So you have a normal image, you pre-process the image through these four new mathematic-based and software-based mathematics, and you get you get new information hidden within the image you already have, the normal image. And then when we gave this pre-processed normal image to a fuzzy logic system, we found the image has changed. Then we gave this changed image to the AlexNet, which is a powerful, to the original AlexNet, to the first contributor to original AlexNet, and by changing the structure of the AlexNet itself, we were able to detect whether the given image is a melanoma or a benign one, non-melanoma one. This was this goes through consecutive steps. This is the main contribution we think we made. The normal image was pre-processed by four techniques, for new software-based techniques, and then the image was given to fuzzy logic, and the fuzzy logic has 4 inputs and 1 output, and then these 4 inputs were defined, were limited within their own limits and rules. I think, if I not wrongly remember, we used 87 or 97 different rules for fuzzy logic, and then the new image was obtained, and then that was given to the AlexNet, but we changed the structure of the AlexNet a bit, and then AlexNet was able to detect whether the given image is a melanoma carrying lesion or a safe, or not a safe one. This is the fuzzy logic system we used. The detail is given in the paper, which is published in the current issue of Electrical and Electrotechnica. So the result we obtained was that. And the original AlexNet gave 0.5 sensitivity, 0.87 specificity, and 0.77 accuracy. But having integrated the AlexNet with the fuzzy logic we developed, we found a bit better results, partially better results, and that was due to the integration of AlexNet with fuzzy logic, because we think it's a good research area for innovative new methods if we could combine the fuzzy logic with AlexNet and other networks, which there are a lot of successful networks there. Then it could be possible to get better results. And the system developed was capable of extracting the hidden data in the pixels and the neighboring environment with the sensitivity, specificity, and accuracy values given in the previous slide. And our publication, our paper was published in Electronica and Electrotechnica. Thanks for this as well. And I think this that's all I could say. Thank you.
Thank you very much. Are there questions, please, gentlemen? Well, I cannot see anybody raising a hand or raising a voice. Let me ask again, please, because that's also an interesting topic and also possibly touching everyone. I'd like to know whether you have been training your system or, well, testing your system with just images taken from databases, or if you have performed also a clinical study with some real patients and real samples of pictures.
Thank you very much. This is a very interesting question, actually. That is our next intention. We are cooperating with our medical school, and but as you know, to gain time, I didn't mention about this point. The medical grade data is very time consuming and expensive to get it. You need to follow each patient during months or years of time, and that's why this paper was based on the available data on the internet, the ICIS data, which is used on international image processing competitions. But our next step is exactly what you suggested and asked. We are coordinating with medical school, and we hope we will get a bit a reasonable amount of patient data, and we could clinically try to see whether the network we developed is actually contributing to the patient's life or not.
Yes. What I'm also curious about, this is also a question of, let's say, obviously there are apparent consequences for telemedicine applications and medical care remotely, like now in lockdown time, it was very important for many people to examine themselves as they couldn't see a doctor at any moment as they would wish normally. But the other question is how precise the pictures taken have to be. Again, the consequences with telemedicine. Is it satisfactory to take just your cell phone, for example, take a picture with your smartphone, focusing on the spot, or is it necessary to comply with some strict measures and strict standards to have the picture examined or tested this way?
And as you know, there are conventional methods which is quite successfully have been used to detect melanoma, but their success rate is greatly depend on the medical experts lifespan in medical science. So their experience is the crucial point in conventional techniques. If you want to use the conventional techniques to detect whether a spot is melanoma or not, its success rate is around 85 or 87%. So there is a huge number there which must be tackled, because it's human life, and 1% is too much. As one medical professor told me, 1% is one life. So for medical illnesses or for healthcare, 1% is very big. Actually, its sentence was 1% is 100%, because it's a life. So we should be careful about this point. But after the data, since the collection of the data is very difficult and expensive, then researchers and other experts, they try to find different methods. That's one of the important. That's why conventional neural network and deep learning was attracting great attention, because they were able, these techniques are able to detect the method, detect the melanoma or non-melanoma case, if the situation is already there. If the situation is melanoma and the conventional methods are not able to detect this illness, but but the neural network and fuzzy logic based and CNN based, deep learning based methods are quite powerful to detect this. Their success rate nowadays is around 84, 85, 86%, which means that there is at least 6% or 4% there, which is awaiting new techniques, new methods to be developed. But the core issue, the core difficulty is medical data. That is why people are trying to produce if you like, a sort of artificial data based on the real data you got from the patient. You got an image from a patient which is melanoma by twisting this image, by giving different level of light and taking the pictures of the image, by rotating of the image, you augment you increase the number of image you have. You actually use people use they get let's say 100 real images from the patient, but through different algorithms and methods they produce 100 or 10,000 or more than new images. By using those images, then it became possible that based on real image, if you are able to create a medical grade image, then it helps to find the patient with melanoma which were not available to be detected by conventional methods.
I see. Well, it would be certainly a long discussion about that. So thank you for the moment. Once again, gentlemen, any other questions concerning this topic, please? Well, if not, I'd like to thank you once again. Please stop sharing your screen. And we will give the floor to the third paper, which is again about networking technologies.
Thank you very much.
As I can see, thank you very much. As I can see, Emmanuel has now switched the camera on, so we do not have to hesitate if he's in Brussels or in Riga. So please let us go ahead with the wireless networking. And Emmanuel, please, it's your turn.
Hi, thank you. Just let me start to share my screen. Okay, can you see the presentation now?
Yes, perfectly. Please go ahead.
Okay, thank you. Hi, my name is Emmanuel, and today I come to present the paper that I wrote in collaboration with Dr. Ingrida, and it's about, well, it's improved restricted access window mechanism for IEEE 802.11ah performance optimization. So, as we saw earlier today, the IoT world or the IoT implementations are growing so fast, actually referring to the forecast made by Ericsson in its mobility report released in 2017. There will be around 29 billion of IoT devices connected by the next year. So it's an increasing market, it's increasing really, really fast. And this market needs an improvement or in the standard, in the network connectivity for the standards. Every day, the standards need to improve on some different areas. Some examples are that they should cover like wider areas. They should also be low power consumption standards, and also they should remain the transmission quality in terms of data rate. I would like to briefly go to some specification about the standard that here on the table we have some comparison between non-IP and IP network standards, some of the most common standard used now for the IoT networking. So on the left side, we have the Bluetooth in the latest version, and on the right side, the opposite side, we have the LoRaWAN that it's an IP standard. Right in the middle, I have the specifications for the AH standard, which it works under the sub 1 GHz frequency band. It can support from 1 up to 16 megahertz for channel bandwidth. It is a low power consumption, and a single access point can support up to 8,000 stations communicating at the same time. Regarding the data rate, depends of the configuration of the standard. It can support up to nearly 8 megabits per second, and the coverage area that can reach it's almost 1 kilometer. Even that I mentioned that the standard can support a different or a wide area, a wide range of channel bandwidth from 1 up to 16 megahertz. There are some limitations and regulations in the regions. Here I have an example of the USA, Europe, and Japan. If you see the common channel bandwidth for all regions, it's only 1 megahertz, even when the standard can work with a higher channel bandwidth. Now I would like to go a bit deeper in the MAC layer of the standard, because this layer has the two most important mechanisms for this standard. So first, at the left side, we have the traffic indication map mechanism, which is basically a hierarchical scheme where all the stations are subdivided in small groups and every station is identified by an ID. So then at the right side, I have the scheme of the restricted access windows mechanism, which is basically a mechanism to restrict the access, the communication from the stations to the access point or to content for the channel based on the ID assigned by the team mechanism before. For the row mechanism, we can find a subdivision by a slot. It means like even when the stations are already grouped, they are subdivided in a slot, so only one station can communicate to the access point at that specific time. Well, this communication of the row groups, it's bounded by this beacon RPS that is basically some flags to indicate the station that they can start communication with the access point. So the problem statement for our research is like most of the research that we found, they were evaluating the row mechanism in a single row group configuration. It means like we need to identify or to create a new algorithm that can work with multi-row group configuration. So for the modeling of the networking or the IoT networking, we use the NS3 software. And if we, well, you can see at the left side, this is the flow diagram, which indicates a process that takes from the access point to synchronize the station. It means like the access point should give the identifier and assign the right row group and row slot to the station so they can communicate at the right time with the access point, or they can start the content for the channel. Then I have the table with all the parameters that we use for the simulations. I would like to focus on the MAC layer parameters, where if you can see, we use multiple row groups that it went from 1 up to 8 row groups, and also multi-slot configuration that it went from 1 to 4 slots configuration. And we use UDP echo traffic, as we saw earlier before. IoT implementations can work with TCP and UDP. Some research that they mentioned that UDP is mostly used for monitoring implementations. So now I would like to show our results. First I should mention that for the set of configuration that we used before, we use a code schema of index 0 that it allows to reach a data rate up to 300 kilobits per second. That is this is the highest data rate that the channel can reach. Configuration. So if we see here in of configuration, we have a mixed configuration, well, multi-row slot, multi-row groups, and with singles configuration with one row group was slot, it was the highest channel traffic flowing during the simulation. So as we increase the configuration in the row, also in the slots, this channel traffic was decreasing. So it means like the channel was less saturated. This doesn't represent the data rate. I will show later the data rate in the channel, but it is just to have a perspective how we can prevent saturation in the channel by using this row configuration. Then here I have the graphs about, as I said, it's packet loss percentage. by also the different row configuration. All these configurations were only with one row slot per row group. So if we see before the 1000 stations working at the same time, there is not such a big difference in the percentage of packet loss. They all remain, all the results remain pretty close to each other. But after we start working with higher number of stations and reach the 2000 stations, we see a higher difference, almost well, it was pretty close to 15% difference from one row group to 8 row groups. So again, we are preventing saturation in the channel so we can get better quality in the communications. Then at the right side, I show the mean data rate and the maximum data rate that we saw during the simulation. And also the trend is pretty the same. For single configurations with only one row group, we saturate the channel, but when we increase the number of row groups, we prevent that saturation. Yeah, now supported the statement that preventing saturation can increase or can perform the quality in the communication. At the left side, I have the graph where we show the average number of packets sent from the access point and the average number of successful packets received. If we see in average, there were sent 8 packets by the access point, but the results were different for each configuration. So with single configuration, with single row configuration, we only reach around 2.5 packets received at the other side. But when we increase up to 4 row groups or 8 row groups, we got a result twice bigger. Like we reach almost 5 packets received at the access point, at the station side. Finally, I just want to show the last graph that shows the power consumption per station. For a small number of stations, well, small in terms of how many stations the standard can support, it's before the 500. The difference in the power consumption is pretty, well, there is not such a big difference. But when we start working with higher number of stations, we can see a bigger difference. Actually, the biggest difference is shown in the 2000 stations working at the same time, where the best performance is shown for the 4 and 8 row groups. This is important to mention because in the long term or in a long-term application for IoT environments, we can save a lot of energy in the devices so that we can implement like more independent solutions, so more less energy dependent solutions. So our conclusions were like working with multi-row configurations can improve quality in different aspects of the communication. Like I showed before, we prevent the saturation in the channel. Also, the quality of the communication was bigger because it was twice bigger the number of packets successful at the station side. So we support that even when the row mechanism is being evaluated on different research, we support the idea that deeper exploration of the row mechanism, how it can work, how we can set proper parameters to bring these benefits to the IoT implementation, it could, I mean, like we open the discussion for further investigation. So that's it from my side. Thank you for your attention.
Thank you very much as well. Now, please, space for questions. Anyone interested to ask something? I can't see. Anyway, the same question from me as with the first presentation given by Istvan. If it is possible to see some documentation of your investigation, your research somewhere so that we can share some data or some results?
Well, currently the algorithm that I use for the simulations is still private on my repository. I just have to discuss with my colleague if at some point we will make this public. But yeah, I base almost the algorithm in the what is public, what is already public from the NS3 developers.
So again, I'm warning you that I'm going to share this information with my colleagues in the research group, and perhaps we will contact you because it seems interesting and there may be some intersections in the research.
Yes, for sure.
Any other questions or inputs, please, gentlemen? Well, if not, then to follow the timeline, thank you once again.
Thank you.
Please stop your sharing. And I'd like to invite the next speaker, who should be Devrim, if I pronounce it correctly. Now we are transiting again to the area of signal processing and image processing. So please let us know what's new in this area. The floor is yours.
Hello, everyone. I hope you can hear me. Okay.
Yes.
Let me share my desktop. Okay, share screen. Where can I find? Okay. Can you be able to see my screen?
Yes, we can see the window of your PowerPoint, so maybe it's better.
And this is PDF document. Does it matter? Okay.
Then Control-L is the good option. Control-L if it's PDF, but it isn't. Or simply using the presentation mode.
Okay.
Thank you.
In this paper, we presented a machine learning method for detecting the trace of seam carving. And in our work, we developed a machine learning approach for detecting whether image is manipulated with seam carving or not. So seam carving is a kind of image retargeting approach, is a manipulation tool for resizing the image while aiming to keep image distortion at low level. And it is usually, seam carving detection is usually interested in image forensics. And so we applied seam carving, and also we developed an approach to detect whether an image is seam carving or not. In our paper, we developed a machine learning method and compared it with the state-of-the-art studies. And our method involves a stripe-based approach together with local binary patterns transform and energy map and some features. As you know, machine learning approach usually involves extracting features. So we also utilized a support vector machine for classifiers. And we also, finally, we compared our results with the state-of-the-art studies, with the recent studies. First, I'm going to talk shortly about literature. As I said, seam carving is a kind of image resizing, while the aim of seam carving is to preserve the content of the image as an alternative to interpolation or other approaches. Is one of the popular methods in image processing, image resizing applications. So, but in literature, there are also various studies to detect whether an image is seam carving or not. So we checked the literature, and we also developed an alternative and improved method to literature. When we look at the studies, because these are usually machine learning based methods, there are also some deep learning approaches, but we're usually interested in machine learning approaches. And we also compared our results with some of the deep learning approaches. I will talk in the conclusion sections. So these machine learning methods usually involves some extracted features such as Markov features, discrete cosine transform, gradient histogram, and the features of seam carving process, for example, noise features and local binary patterns, local derivative patterns. We also utilized local binary patterns in our study. For example, Weber local descriptors. There are various methods based on machine learning. And there are also convolutional neural networks for this used for this purpose. And as you know, convolutional neural networks extract their features by using the finite layers, and therefore they don't need specifically extracting features, but sometimes specifically extracting features may help you to obtain better results when compared with deep learnings. So first, I'm going to talk what is seam carving and some basic topics, and then I'm going to talk about our method. A seam carving, a seam is described as an 8 connected path of pixels along the top to the bottom or left to the right. So during seam removal, you can remove seams in the horizontal or vertical directions. So seam carving is a content aware, and it's what do we mean content aware? It doesn't it's with the help of energy map, it usually removes unimportant paths, so it helps to preserve the content of the image. But there are some when you remove a lot of seams, it also disturbs some content, some objects in the image. But in practice, the aim of seam carving is to preserve the content of the image. In this method, an optimal is seam found and removed or inserted one by one until the desired image size and other stepping conditions are satisfied. So it is usually applied with computing energy map or various approaches for this purpose. And then cumulative energy map is computed, and based on this cumulative energy map and the summation of these pixel values helps you to determine the optimal seam. So there is an example for this. This is the energy map obtained at one of these approaches. And once you compute energy map, for example, here, energy map. Okay, let me find the pencil here. Here, this is the energy map of in image, as you see, and these numbers are cumulatively somewhat below, starting with the second row. For example, this 80. Okay, this number is somewhat with one of the smallest pixels, and then this one is also somewhat with smallest one. For example, this one. As you see, this pixel is a neighbor with these 3 pixels. So this map is, excuse me, let me find the numbers. This map is formed by summing these pixels based on the minimum values, minimum neighbors. So once you obtain this minimum cumulative energy and you check the path, start with the minimum value, minimum number, and find the path with minimum values. We are trying to find the path with minimum values, but at this point we are checking only the neighbors. For example, the minimum value of 75 is 191, and the minimum value of 191 is 301. In this way, this gives us usually the unimportant path of pixels. So this is the application of, this is the main idea of seam carving. So this is an example, paths removed from the seam. From the image. This is the energy map. These are the remote paths. And because in our machine learning method, we utilized local binary patterns, maybe this is one of the basic methods, but I'm going to talk about it concisely. Local binary patterns is usually used for extracting texture features. It's called as visual descriptor, and its features is usually utilized in machine learning applications. The images are generally divided into 3 by 3 cells, or sometimes 5 by 5, but in general, 3 by 3 is preferred. And each window, 3 by 3 window, is converted to a binary number by comparing the pixels in this window with the center pixel. For example, in this example, in this for these values, the comparison is start with this pixel, but you can change this. For example, you can use this the first as a first pixel, and in that case, you need to apply this to all pixels. Yeah. In other words, you need to fix the starting pixels for all windows. So once you select the first pixel, you compare it. For example, the center pixel is lower than the neighbor above. Then we set it to 1. We set it to 1. And then this one is smaller, then set it to 0. So once all the neighbors are okay, we control them and we form a binary number. And this binary number is the local binary pattern. This is a very useful approach for extracting. Maybe I had better to put here an image, local binary pattern image. It gives us some details of the image. It's very useful for machine learning classification applications. In our paper, our contribution, actually the main contribution here is to provide a better machine learning method. And for this purpose, we used a stripe-based approach. We divided the image into stripes, and we also utilized local binary patterns. And also we utilized some features. I'm going to talk about them. And we also realized that taking the square root of this, the energy map provides better results. So we also take the square root of the energy map. And we called our method stripe-based seam carving detection method. And as I said, we divided the image into stripes and utilized some features such as local binary patterns and some statistical features. So we determined the number of stripes. We checked various number of stripes, and we determined the best stripe. For example, for our case, we used 6 stripes, but here is an example: 2 stripe case, 4 stripe case, and vertical or horizontal. And so this helps us to find, this helps us to improve our machine learning approach for the detection of seam carving, as I talk in the conclusion section. These are the other features. These are extracted from the images. These are some statistical features. For example, maximal value of a stripe, minimum value, horizontal and vertical directions, standard deviations, and differences between the neighbors stripes. And these are the extracted features after local binary patterns. First, First we convert our image to gray image from RGB, from color image to our gray image, and then we apply local binary patterns, and then we compute energy map, and these are the we also took, especially we showed this here because nobody used this in this way. We saw that this is useful to improve the features, and then we divided the image into stripes and then applied the statistical after minimum cumulative energy map, we applied the computed to scene features. So these features are the features here, statistical features. And according to the number of stripes, the number of features are also increased. And these are used for used as input to our support vector machine. And as a data set, we used UCID data set. We use this because in literature, most of the authors use this data set in order to do a comparison. We use this data set. It contains 1,338 images, and these are 512 by 384, or the rows 384 by 512. So because the level of seam carving affect the detection rate, we used various rates. These are the preferred rates in literature. Also, we forget to write here. We also, because in the papers we saw 40% and 50%, we also used this. And after application of these ratios, our data set becomes about 8,028 images. And
sorry to interrupt you.
Excuse me.
You have to do it faster because the time is almost over. So please.
Okay, I'm finishing it.
2 more minutes. Yeah.
Okay.
Thank you.
I am finishing it. This is, as I said, this is our main approach. We processed all the images, and this is the basic idea of our approach. And there are okay, and we did some comparisons here. As you see, we tried 1 stripe, 2 stripe, 4, 6 and 8 stripe approaches. For our case, we found that 6 stripe is good, but because our image is fixed to a certain size, this may differ for higher dimensions. For example, 8 stripe may work on higher resolutions. So when we compare with the state of the art, and we are good at most points except some smaller ratios. For example, 3% scaling is difficult to detect. So a deep learning approach is better than us, but for the other cases, our approach outperforms. So we mistakenly wrote this to the paper because I realized that we also are good at 30%. And so in conclusion, we developed an efficient machine learning approach based on some extracted features, but the recent trend is in various areas is to use a deep learning approach. And we are also doing some experiments on deep learning approach, and we obtained good results, but we haven't published it yet. And also another open topic is the localization, such as I saw some approaches like YOLO or other deep learning approaches for detecting the place of seam carving, for locating the position of seam carving. Also another point, all the literature used fixed size images, and it is necessary to use various size images in various images in various dimensions required to obtain better performances. That's all I want to say. If you have any questions, I can answer. Thank you for listening.
Thank you very much. Also, perhaps there is time for one fast question. Please, gentlemen. Since this is not directly my cup of tea, I'd like to pass the word to anyone. If not, then thank you for the moment.
Thank you.
Because of time constraints, I'd like to pass the word directly to Zoran Cica from Belgrade, and his again, networking topic concerning IPv6 lookup. So please go ahead, Zoran.
Okay, I'm just a second. Okay, I hope you see the screen. Okay, hello everyone, I'm Zoran Čiča and I will present this paper about the IPv6 lookup algorithm. I come from the Belgrade University School of Electrical Engineering. So IP lookup is one of the critical routers functions, even for the IP version 4 addresses, but also we expect at some point in the future that IP version 6 will finally become a dominant addresses in IP space. And the problem is that most of the existing IP lookup algorithms are practically adjusted, suitable for IP version 4 lookup tables, but do not scale well for the IP version 6 lookup tables. So there is a scalability issues with the existing IP lookup algorithms. IP lookup practically performs for each incoming IP packet. It searches the lookup table. The search is based on the destination IP address, and based on that search, we determine to where the IP packet should be forwarded, to which output port. And the worst case scenario that IP lookup needs to support is when only the shortest packets are incoming at the input port, because in that case, IP lookup has practically the least amount of time to perform its function. One example is given here: 100 gigabit per second Ethernet link, shortest frames are 64 bytes. So practically IP lookup would have around 5 nanoseconds to perform its function. And it's a very, very short amount of time. So IP lookup needs to be very, very fast. And that is one implementation problem. The other problem is that when we look at the core routers, well, the number of entries can be very large, hundreds of thousands of entries. But on the other hand, the lookup tables should be small, and that is also a sort of scalability issue. The algorithm needs to, make modest requirements for the storage of lookup tables. There are several classes for IP lookup algorithms. One of them is a tree-based lookup algorithm. So this class is very popular because the tree structure represents practically a natural way to store the lookup table. If we look at these prefixes that are stored in this tree, and for example, let's say that our IP address starts with 3 zeros, then we would follow this path. Left branch is 0 and right branch is 1. So we would follow this path. We would find two matches, A and C prefixes. And practically, we always choose the longest prefix according to the longest prefix matching rule. And in this case, we would select prefix C as the entry that we want to retrieve, and we would find out to which output port the packet should be forwarded. However, there are two serious problems with tree structures. One is the number of empty nodes. Of course, this is very small tree, but in reality, the trees are greater. And the number of empty nodes is very, very large, especially in the IP version 6 case, because most of the prefixes are deeper in the tree from levels 32 to 48. So this means that many empty nodes that do not carry actual information, they are just needed to keep the tree connected, are practically requiring very large memory storage requirements. And the other problem is that each node is actually, in most of the cases, one memory location. So practically, we need to have multiple memory accesses to traverse the tree, and that slows down the lookup process. It would be ideal that practically we have only one memory access per one lookup. So let's see how these problems are solved in the literature. Well, the problem of empty nodes is solved by using so-called priority trees. So what is the story behind the priority trees? Practically, we have some empty node in the classic tree. So we look up to its descendants, find the longest descendant, longest prefix descendant, like G in this case, and we move this information about the G in this empty node. Similar goes for this node. We have two candidates C and F. For example, we move F here, we move E here, and so on. So at the end, we have something like this. This is so-called priority tree. where we have no empty nodes. Of course, the price we pay is that practically we need to store the actual prefix in the node, because now it can be different from the path. It can be longer than the path to that node. But this is justified because there are no empty nodes, so the memory savings are still very, very great. On the other hand, to avoid multiple memory accesses, well, we cannot avoid actually multiple memory accesses. It's natural, but we can sort of use a pipeline, and we can virtually achieve that we have one memory access per one lookup. How is this naively done? Well, it can be done that each level in the tree can be stored in the different stage. Each stage 1, 2, 3, and 4 has its own memory, and practically it stores the nodes from that level. So actually, when one lookup starts, it goes to stage 1. After the search, it follows the path and goes to stage 2, then stage 3, etc. But once this lookup passes from stage 1 to stage 2, new lookup can start at the stage 1. So we can have multiple lookups at the same time, and virtually we achieve one memory access per one lookup. However, the problem with this naive approach is that the memory sizes in each stages memories are different size, and this is not good for the implementation. It would be more suitable that these memories are the same, and this proposed solution in this paper tries to solve this problem. We proposed here the balanced pipeline lookup. This is the general architecture, and the general idea is the following. The original binary tree is split to subtrees at the split level 16. So selector practically takes the IP address, checks the first 16 bits, and determines to which subtree search should be performed. Then practically search is performed in the pipeline stages. That is where the subtrees are stored. And at the end, we get the solution, the best match that points out to the location in the next hop memory that practically from where we retrieve the next hop information, that is where the packet should be forwarded. Just to note, the subtrees are actually priority trees, so there are no empty nodes. And this significantly reduces the memory requirements. Also, the pipeline stages are balanced. We will see that later. And the memory sizes in each pipeline stage are the same. So this is good for implementation purposes. So this slide shows how this balancing is achieved. Well, practically, the most important thing is that the ancestor node and its descendants needs to be in different stages. And this ancestor node needs to be in the prior stages. That is the only requirement. So we have, for example, also node A. Here it is, it's in stage X, but even though that C, D, E, and F are in the same tree level, they can be stored in different actually pipeline stages. For example, I can be different from the Z. Also, to reduce the memory requirements to reduce actually the number of pointers, this node A has two descendants, C and D, direct descendants. But we place C and D in successive locations, so there is a need for only one pointer that points, for example, to the left child, and we know that the right child is one location above. So in this case, we can easily manipulate the contents of the pipeline stages, and we can easily balance the number of nodes between the stages, so we can have the same memory requirements. And by having the split level 16, we have enough, enough subtrees that we can easily populate in the same way the first few stages to avoid slow starts and less memories in these first stages. This slide shows the architecture of one pipeline stage. It shows only the lookup part, not the update part. And the main part is actually this stage memory. Stage memory is dual port memory, when one port is dedicated for the read operations that are used in the lookup process, while the other port is used for the write operations that are used for the update process. Practically, this comparator checks whether we have reached the stage of interest or not. If we have reached the stage of interest, that is where the node that we want to inspect resides, then some additional operations will be done. But if we have not reached that stage yet, then all these inputs are simply passed to the output ports until we reach the stage of interest. If we have reached the stage of interest, then this comparator practically compares the prefix with the IP address. And if the comparison is positive, that means we found the new next best match, then this multiplexer will practically pass this new result. Otherwise, if there is no match, the old result would be passed. One location contains two parts, two informations. One information is the prefix, actual value of the prefix, and the second information is the pointer value. And the pointer comprises two parts: location ID, that is the location in the stage memory, and the stage ID, which stage should we look. And the result is actually the pointer, because each location in each stage memory from any stage practically corresponds to one location in the next hop memory. So practically this location plus, that means concatenated with the stage ID, practically represents the location in the next hop memory from where the next hop information is retrieved. This multiplexer practically, when we reach the stage of interest, now we need to check the next node. So this multiplexer selects the new pointer, because now we point out to the next node we want to inspect. Of course, in the network, frequently there are a lot of changes in network topologies. For example, router can fail, links can fail, routers can be added, links can be added, and etc. So routing protocols will frequently update the lookup table. However, the important thing is that update of the lookup table should have a minimal impact on the IP lookup process, in the sense to minimally disturb the IP lookup process. So that means actually that the updates should be incremental, and we should avoid to rebuild the lookup table. Also, the updates should be fast and simple to fastly follow the network topology changes. This slide shows one example, the most complicated example of the update scenario. I will go briefly just here. We had practically prefix 5, that is the longest prefix in this observed subtree. And to see how the balancing works, the currently least popular at that point of time, the least populated stage is, for example, stage 2. So we want to add practically a node in the stage 2 to balance the number of nodes across the stages. But the problem is that we cannot put prefix 5 here, because it's longer than 2, 3, and 4 prefixes. So actually we move 2, 3, and 4 to these prior stages. 2 will move to stage 2, 3 will move to stage 4, and 4 will move to stage 6. And we now in an occupied space can put this prefix 5. However, the most important thing here is that all these calculations are done in the control plane. So actually, this proposed algorithm can go is in line with the software-defined networking, in sense that the control plane and the data plane can be decoupled, and all the calculations are done in the control plane. And actually, control plane just sends to data plane pairs address value, where address is practically the pointer stage ID plus location ID, where the data should be written. And the value is actually data that is written to the tables and to stage memories. And practically based on the calculations, a batch of these pairs address value are sent to the data plane, and data plane just sends it to the pipeline stages. And it's written using that other port in dual port stage memories. At the end, we compared the proposed algorithm with some other tree-based recent algorithms, and we used for the comparison on-chip memory requirements. The reason is very simple, because there is a need that the lookup algorithm should be fast. That means that we should have one memory access per one lookup. And that means actually that we need to have multiple memory instances. So the natural choice is to use on-chip memory for these memory instances, for example, on-chip memory on FPGAs. And of course, the other requirement is that these requirements should be low enough to fit the total on-chip memory. Based on this table, we can see that BPL actually has the least memory requirements. And also it can support very well even very large lookup tables. So all the requirements are fulfilled. So as a conclusion, I will just summarize things. The proposed algorithm can achieve very high lookup very high lookup throughput, while still having very low frugal memory requirements. And actually this helps to support very large IPv6 tables. And the plus is that table updates, lookup table updates are very simple and very fast, and they are in line with the SDN principles that are actual today. I hope I was fast enough. So thank you for your attention.
Thank you very much. Once again, I'd like to ask about any questions. Please, gentlemen. Well, perhaps could you please give us an example to have a brighter idea, an example what I could expect from this type of algorithm or technique in a live network, I mean in practical networking applications. So
okay, well, I didn't put it in this presentation because of the time, but well, that depends actually on the size of the table. For the smaller routers, this algorithm is very suitable for hardware implementation. The paper itself has an example of the FPGA implementation, how many resources are used. But the thing is that mainly depends which router we are targeting. If we are targeting the routers that, for example, are on the edges that should not have very large how to say, lookup tables, then these small FPGAs can be used and it will be a very economic solution. However, if we target the core routers, then we need to use high-end FPGAs, and that can be problematic because they are pretty expensive. But that is the price you pay for the core routers. I mean, core routers need to have, how to say, high performances. So that is just a question about the lookup table size. The logic itself, as it can be seen here, is very simple. So the only question is how many these stage memories and how big they should be. And that is the main question. All the calculations are done in the software, in the control plane, so this is not a problem. This is not, how to say, implementation issue or the resource issue. But these stage memories are critical. So this is the main question, how big the lookup table we are targeting. The bigger the lookup table, that means that the higher end the FPGA chip should be used. But in most of the routers, this is not necessary. So actually, this can be a very economic solution.
So you can see the future in a routine integration with standard network elements and devices.
Yes, we hope that, but we will see it, because this is now also the question about the how to say, targeting the producers, because usually producers have their own solutions, so it's a bit tough. But we had the project that is still going on regarding the small routers integration. So we hope we can use it there and we could commercialize that product, but it's very hard.
Thank you once again. One more time. Any questions from anyone else, please? If not, thank you. Please stop your sharing. And I'd like to invite the last speaker in this session, who is from the University of Istanbul. I'd like to pronounce your name, Temel Sönmez-Zocak, right? More or less.
Hello, everybody. Hello.
So please.
Can you hear me actually?
Yes, we can. Okay. Although the sound quality is not very impressive, but hopefully it will be at least comprehensible. So please go ahead with your topic concerning, again, medicine and diagnostics and evaluation of signals, please.
Okay. First of all, thanks to your organization to give a chance to present my work. I'm Temel, the PhD doctorate student of the Yıldız Technical University, and also I've been working at the Haliç University as a lecturer. My topic is the detection of the electromagnetic signals by neural networks using autoregression and wavelet entropy for precision diagnosis, which had been published in Journal of Electronica last month. Our topic is the introduction and materials and methods that consist of the electromagnetic signals acquisition and processing, and electromagnetic feature extraction using autoregression modeling, and we clarify the electromagnetic feature extraction using discrete Fourier transform, diagnosis of the bruxism by neural network classifier, and we will finish the experimental results. Bruxism is a chronic dental problem seen in many people today. Its treatment is difficult, has a low success rate. Bruxism is defined as a perfectional grinding of the teeth and involuntary contraction of the lower jaw muscles. So in bruxism patients, hypertrophy in masticatory muscles, tooth wear, implant fractures, tooth loss, and fatigue and pain in jaw muscles can be seen. These symptoms are due to the application of a force that is very high for the physiological structure by the involuntary contraction of jaw muscles. Recently, studies based on joint analysis of echocardiography and electroencephalography (EEG) signals, together with surface electromyogram, have been carried out for the clinical diagnosis of bruxism. However, these methods for clinical diagnosis of bruxism are costly and time-consuming, and they require specialization. For this reason, the golden standard for bruxism diagnosis, especially during sleep, is the evaluation of electromyogram of the masticatory muscles together with audio-video recordings through polysonography in a sleep laboratory or hospital setting. But it's very complexity, and it's a high cost of this method. It's a disadvantage. Therefore, it's crucial to develop practical, efficient, and economical solutions based on only use of electromagnetic signals. So we design an electromagnetic measurement system in the home environment. In the study, to achieve an accurate diagnosis of bruxism economically with only electromyography measurement, an even approach based on the autoregulation and Shannon entropies of discrete Fourier transform energy spectra to identify jaw muscle activities and fatigue conditions is proposed. By using artificial neural networks in the proposed model, bruxism activities can be detected most accurately. Electromyogram signal acquisition and processing we mentioned. The experimental setup used for acquiring data from the subject is shown in this figure. A dual channel data label was designed for surface electromyogram signals to collect from the skin surface. Electromyogram signals received from the skin surface were amplified with the instrumentation amplifier. It's a very high gain. The amplified signals should be free from noise, since the meaningful frequency of the electromyogram signals obtained from the muscles is within the 10 Hz and 500 Hz range. A second order Butterworth bandpass filter with corner frequency is 10 Hz and 500 Hz was designed in this section. So for the recording of measurements, bipolar electrodes of 50 mm diameter were placed on the skin surface over the masseter muscle of the subject with 1 centimeter intervals, and calibration and normalization has been done. Then analog electromyogram signals are digitized and transferred to PC environment using the prefrontal system. Data received from the subjects are sampled to have 4,500 samples per second. The data are analyzed by using MATLAB software in this environment. As you see, This is the electromagnetic sequence of the pulse of the subjects. For example, the A sequence is relaxed, and the B is the muscle is closed or clenching, and the C is the fatigue and pain, and the D is rhythmical teeth grinding. It's a parafunctional activity. To identify these stages, unlike other Bruxism-related studies in the literature, discrete weather transform and autoregression models are used together to extract the most salient features from each electromagnetic signal from these two methods. 20 different parametric coefficients are obtained for each electromagnetic signal of 1 second period. You can see the block diagram of the electromagnetic recording system. Considering that there are 125 different electromagnetic signals collected from each subject, a total of 2,500 data are obtained. The block architecture of the proposed model that outlines the entire study is shown in this figure. You can see. Electromagnetic feature extraction using auto-regression modeling that we mentioned. Auto-regression contains important state parameters of the system and is of great importance for time series. Unlike since it's very sensitive to time-dependent changes in the system, this model is an important one in terms of capturing the key characteristics of any data set. In this formula, you can see the autoregression model A1 to up to A12. This is the feature. This is the most important parameter. These parameters can be used in feature selection from electromagnetic signals for Bruxism diagnosis as coefficients of order 12 that represent X time series. We mentioned that electromagnetic feature extraction using discrete wavelet transform. This is the two important functions are involved in the application of discrete wavelet transform to an electromagnetic signal. First one is scaling function, and the second is the wavelet function. To decompose the signals into different bandwidths to calculate the coefficients, CK in the scaling function and the BK in the wavelet function, it should be passed through a high-pass filter and low-pass filter shown in this equation, as you see. So we taken the tail components, especially DT and approximation components, using these coefficients. DT is a very important parameter because we use DT to calculate the AG key. AG key, which means channel entropies. It's the very, it's a feature, it's the input feature for the diagnosis of the Bruxism. AG key, the tail component expresses the tail component obtained through wavelet transformation in the frequency domain, depending on the sampling frequency at G and time t. Hence, wavelet channel entropy of each tail component shown in this equation can be calculated easily. Diagnosis after taking the features, both autoregression and wavelet energy entropies, then we using the neural network classifier in order to classify, detect the bruxism diagnosis accurately. In the study, autoregulation coefficients and deviate channel entropy values of the 125 different electromagnetic signals obtained from the subjects for the case of perfectional teeth grinding, jaw squeezing, and the resulting pain or fatigue that occur during bruxism compress the input to the multilayer perceptron. For this reason, two different network structure with respect to the input characteristic of the electromagnetic signals are formed. This structure shown in this figure. In this figure, each data are divided into three groups. Ratio, such as training, validation, and test with respect to input characteristics of the created structure. The number of neurons for the hidden layer was determined as 10 in our study. To investigate the performance of the method used, the classification accuracy was calculated according to this formula. In this formula, here in N is the number of classes, and CCS is the number of correctly classified samples. TNS is the total number of the sample, which was obtained from the completion matrix. We mentioned that the experimental result can be seen that multilayer perceptron structure with much higher performance can be created when autoregulation and variational entropy parameters. This created structure can be trained quickly with high performance using Levenberg-Marquardt algorithm. In this figure, the correlation performance of the network according to the input characteristics. Both features is autoregulation and variational entropy is the very high accuracy. As you can see, the performance is 0.98. It's very, very high.
If I can ask you, go right to the conclusions because we are short of time. I'm sorry for this, but we've had a long presentation before you, so please make it as short as possible now. Thank you.
Okay. I know there's no time. I had to hurry up. As a conclusion, this study, unlike other studies in the literature that consider electromagnetic signals for bruxism reactive disorder, jaw locking and random teeth grinding movements are considered together with pain and fatigue in the jaw muscles as a whole. An effective system for accurate bruxism diagnosis is proposed. And also, by virtue of its being based on the design of a system that records on electromagnetic signals in a home setting without the need for a laboratory setting, the study is a practical and low-cost system. Activities that occur during bruxism should be recorded real-time through electromagnetic signals, and the most effective features should be extracted by way of time and frequency analysis. This way, the signals acquired from the EMG measurements can be classified with 100% accuracy by neural network algorithm by using both autoregulation coefficients and variational entropy coefficients obtained from relative transform of the same signals. With the approach proposed in this study, when the cost and time spent for using only electromagnetic data are considered, its practical method for wearable or portable electromagnetic devices and a suitable approach for the effective use of therapeutic wearable electronic stimulations in the future studies. Thank you for listening.
Thank you very much. So one more last time. Questions, please.
I know it's too late, so I hurry up.
I'm sorry for not keeping the time schedule before, and I have to make it faster in this very last moment. My question would be: so, if I do understand correctly, you assume that the system proposed like this shall be able not only of diagnostics of the problem, but also of therapeutic application. Am I right?
Yes, it's true. This system is very easy to use. System records the data during the sleep, then they convert the digital system in order to detect bruxism in PC environment. All lower jaw muscles activities can be detected in 100% accuracy. Afterward, we're planning to minimize the system for using home environment. Meanwhile, during the sleep, all lower jaw activities is not related to the bruxism. So it's very important thing is to distinguish the meaningful signal for the diagnosis of bruxism.
Yes, thank you very much.
You're welcome.
Gentlemen, thank you for attending this session this afternoon. As I've said, we have run almost also of the break between the sessions. So I'd like to thank you once again to conclude this session. Thank you very much for your contributions. As for the questions and discussion, I'll send the emails to some of you, perhaps after discussion with my own colleagues. The contacts are also in the papers, so please feel free to contact each other if you are interested in the results of the other colleagues. And thank you. Have a nice afternoon. And the next session shall start in some 3.5 minutes.
Okay, thank you.
Apologize.
Thank you for all of us, all of you.
Apologies to Darius.
Thank you.
Bye-bye.
Okay, thank you. Thank you for the presentations and sharing as well.
Okay,
See
thank
you.
you, Darius. Bye-bye.
Bye-bye, everyone.
Okay, we should prepare for next our session.
Okay, Darius, so I'm here as a chairman.
Yes, Michal.
Good.
Okay, so the first one, Dardan, is already here.
Hi to everybody. I'm here.
Pavel Shimon is here. Maria Nova is here as well. Ahmed. Yes, it's here. Teresa. And Teresa. Yes, maybe the last one lady is missing, but I hope she will join. Okay, so 2 minutes left.
Okay, couple of minutes.
Zdravím do Žiliny, předávám slovo.
Okay, so maybe I can just briefly discuss with the presenters. So I think that everybody already knows the procedures, so please try to finish your presentation in a given time, also to have some space for discussion. And if it will be required, I will ask you to speed up or slow down. And it is also fine if you will make a short and brief introduction of yourself, as I do not have detailed information about the presenters, and maybe some of the presenters will be different as are listed in the program. Okay.
Yeah.
Good. So we will wait 1 minute and we will start. Fine. I think that we can start because most of you are here. Also, the audience is presented. So welcome to the session 9A, the renewable energy. My name is Michal Frivaldsky. I am from University of Žilina from Slovakia. So welcome everybody. The first paper will be presented by Mr. Dardan Klimenta, and I am giving to him a word, so you can start with sharing of your presentation and your paper proposal.
Okay, thank you for giving the opportunity to present my work, dear Professor Frivaldsky. I will share my screen first of all with you. Do you see my presentation on the group?
Yes, it's okay.
Okay, I will enter now this full screen mode and I will start with my presentation. Today I will present the paper entitled A Novel Procedure for Quick Design of Off-Grid PV Water Pumping Systems for Irrigation. The name of my co-authors are Julijana Lekic and Dragana Radosavljević, and they come from the same university as I, from the Faculty of Technical Sciences, University of Pristina in Kosovska Mitrovica. Other co-authors are from two different universities. Dragan Tasic and Nikola Krstić comes from Faculty of Electronics Engineering, University of Niš, also from Serbia, and Sanel Arsic comes from Technical Faculty in Bor University of Belgrade, also from Serbia. I'm Dardan Klimenta, and I will present this paper now. First of all, this paper contains a lot of formulas, and I will try to present it in a brief way, avoiding equations and too long explanations on them. Because of that, this introducing section is a little bit longer. For example, I listed all the novelties here in introduction, and this is, according to my belief, the best way to present this paper, which is very rich with details and numerals and equations. For example, this paper proposes a novel procedure that uses the sunshine duration, precipitations, and ambient temperature as inputs. The inputs were collected and taken from the weather online UK service. The effects of different data collection periods and data availabilities are also analyzed and considered in this paper. The proposed procedure also uses as input data sheets from manufacturers for pumping system and PV modules. There are other similar procedures that uses meteorological variables as inputs. For example, one of these softwares are Lorentz Compass software. In the paper, we listed a number of other softwares which operates in similar way like this procedure. Compass uses the solar irradiation, precipitation, and ambient temperature as inputs, which were collected by the NASA Langley Research Center. For example, this is the first novelty between these two procedures from the compared them, our and this which is embedded in the Compass software. For on this slide, for all the novelties from this paper are listed. The second one is the introduction of conditions concerning the dirt losses in the design procedure. The third one is the collection concerning the total number of required modules, the required minimum number of PV modules in one string, and the number of required strings in one PV generator. For example, there are many ways to express these conditions, but comparing our conditions with the existing ones, we found that these can be considered as novelties. The fourth novelty of this procedure is the use of modified Sivkov model that correlates the global normal irradiation with the sunshine duration, elevation angle of the sun, and monthly optimal inclination angle. For example, this novelty can be also considered as the main contribution of our paper. The fifth novelty is the calculation method of the electrical parameters of the PV generator. That means output voltage and output current. The last one, the sixth novelty of this paper, is the use of the monthly mean value of daily global normal irradiance instead of a number of monthly mean values of hourly global normal irradiances, or the peak global normal irradiance. What to say, to add to these novelties is an existing PV pumping system designed using Compass is used as a reference for the purposes of comparison and validation. That means like a case study. The results of the comparisons showed a high level of accuracy, and a number of interesting conclusions are drawn from them. The proposed procedure was also successfully validated. On this slide, we can see layout of the water pumping system for irrigation. For example, I will avoid to list all the components of this system, but the main I will list only, I will mention just the main components of this system. For example, this is pumping system labeled with the number 2, PV generator labeled with number 15, and controller PS2 1800 labeled with number 1. And some remarks, for example, this schematic presentation of PV water pumping systems contains some differences compared to the real one which is consistent in this paper. For on this slide you can see two real photos taken during the installation of PV generator and components of this system in the small village called Zabela nearby the Požarevac in the eastern Serbia. For example, you can see two projections from the front side and back side of a PV generator. And if you read the paper, you can see that the generator has 18 PV modules, but on the roof we can see 20 of them. For example, 2 of them are source of electricity for one small independent of grid system, with batteries running the other devices, chargers, LED lighting, and so on. For example, if we see once again this previous slide, one reservoir tank, water tank is existing on it, but in the practice we do not have it. This is realized with one, how to say, water pressure of 2 bars, which is equivalent to a height of this water tank. And this is irrigation system, dripping system. For example, on this slide, you can see wiring diagram of the PV generator. Also on the right side of this slide, you can see the manufacturer of PV modules which are connected in this 3 strings, and altogether there are 18 PV modules, and they are connected to the controller PC21800. For example, avoiding to explain all the formulas appearing in our paper, I just take this performance charge for the PV water pumping system, just to show to you some details related to the system. For example, in main reference 1, output flow was 5 meters cubic meters per hour, but in our case it is a little bit higher than it. And also we had in our calculation some differences in pump input power. Manufacturer of this pumping system is the same company, Lawrence, who they are also manufacturers of software compass, which is used for the purpose of comparisons in this paper. On this slide, we can see Sivkov model. Really, this Sivkov model can be found in the literature under the name also like Sivkov empirical correlation or just Sivkov correlation. And this correlation was originally developed for the latitudes between 35 degrees and 65 degrees north. And I take just 2 formulas from our paper and presented original Sivkov model and modified Sivkov model. This the second equation is our contribution and one of novelties presented in this paper. For instance, with this slide, I will start to present our results, obtained results of this study. For example, this table represents a comparative presentation of the results obtained by applying compass and our proposed model. For example, columns labeled with compass relates to the Lorentz compass software, and columns labeled with double P, they contains results obtained by us. And comparing all of these numerals, we can see that the differences are minor and negligible between 2 models. Some differences, of course, exist, but I will remember them in the concluding section. This is this slide shows the first chart shows the monthly mean values of daily ambient air temperature. The values colored in with black with dots are from the NASA Langley Research Center. By the second one comes from the Weather Online UK service. And these are inputs not calculated by us. Also in the second chart shown on this slide are also inputs taken from the services. Bars labeled with A are also from the NASA Langley Research Center, while the second one are from the Weather Online UK service. This second chart presents monthly mean values of daily precipitation in millimeters per day.
Dear Dardan, I think we should go to the conclusion because...
Yeah, I'm near. This is last one. I was so quick. These two charts shows our results of our calculations. The first one shows the monthly and seasonal mean values of daily global normal irradiation on a south-oriented surface inclined at 25 degrees in kilowatt hours per square meter and per day. On the second one, we can see the monthly and seasonal mean values of daily electricity generation from PV generators. Both are presented together with the results calculated by Compass, and reader can see differences between our and the existing ones, differences between results. And the last one for chart, the diagram shows the monthly and seasonal mean values of daily water production. Differences also exist between them, and I will remember them in the concluding sections. The first one, conclusion, I remembered it in introducing section, and I will avoid it now. The most important conclusion is the second one here. The application of the Sivkov empirical model resulted in overestimations of available solar energy in average by about 20 degrees, and electricity generation in average by about 5.5% at the considered site. But there was no need to redesign the PV generator. Compass gave solution with 18 PV modules. Also, we get the same one with 18 PV modules of the same type. The daily water production for the month of May, having the lowest global normal irradiation value in the irrigation season, is by the 13.75% higher than daily required amount of water. This confirmed that the proposed procedure is in line with the relevant standards. Both the proposed procedure and software Lorentz Compass gave the final design solution consisting of the same components. It is shown that parameters such as the data collection period and data availability can affect the values of meteorological variables used in the design procedure of the off-grid PV water pumping systems. Accordingly, it's recommended that the data collection period should be equal to or longer than 20 years, and that the data availability should not be less than 70%. I didn't have time to discuss this issue. This is just said as in this mentioned in this conclusion, and it will be left to the readers to see our old paper, which is published in our journal. Also, it is found that there are no significant differences between the values of meteorological variables, which can be. It is also found that the presented worth of the costs for the considered PV pumping systems is $19,760 US, excluding costs for the diesel-powered electric generation and piping. Thank you for your attention and sorry for over timing.
Yes, thank you very much, Dardan. So yes, the paper is a little bit long, so it was also necessary to present all the results, and it is seen that they are also practically verified. So very good. Maybe one question from the audience, if there is some question. Okay, so maybe later, so you can write it in the chat, and then you can have also a discussion after the session. So thank you once more. And
thank
now,
you, dear Professor Kowalski.
Yes, now we can continue to the second contribution within this section. So I would like to welcome Mr. Pavel Shimon from University of Žilina. So he's a colleague of mine. He's acting as an assistant professor. And now I would like to ask once more, Dardan, you should end sharing the screen.
Yeah, I'm trying, but
it's not working. Yes, now it is good.
I'm closed. Okay, it's okay now?
Yes, it's good. And now I would like to ask Mr. Shimon to start sharing so we can see the presentation. So please, you can make the presentation of your paper.
Thank you. I would like to present papers of technical potential of built-up area in the Slovak Republic to produce electricity from solar radiation. I am from Žilina University as our chairman, from same faculty, but from different department. And we were working, two of us, me and my colleague Michala Hola. Introduction, I will divide it in this parts of my presentation, and this research wasn't supported by any grants, only by my earnings in faculty. That thank you faculty for supporting this research. Purpose of this research was our commitment to our children to leave them beautiful earth more harmed than before. Of course, EU and our country commitment, and I need to say that renewable energy sources are quite different from traditional energy sources. It could be distributed everywhere, but could be really volatile, could be close to consumption, and they have a huge variation of generator size, from one panel to many megawatts. And sun deliver a base portion of energy, but we still cannot use it very efficiently. But how many this energy can we use? That is purpose of this research. At first, I need to say there is plenty of tools to evaluate any individual place of PV production. One of the best is PV GIS from GRC of European Commission. It's free tools on web, and you can evaluate any point in Europe, part of Africa, and part of Asia. Next very good tools for point evaluation is PV Planner from Slovak commercial company SolarGIS. and they have more than 50 years of meteorological data and satellite data with 15 minutes granularity. But all these tools are useful for evaluation of exact PV installation site, but is not useful for evaluation of huge area as in Slovakia. But from these tools, we can say that PV production in Slovakia varies in ideal condition from 900 to 1,250 kilowatt per installed kilowatt peak. Next thing is what we need cover with renewable energy. Slovakia is one of the largest country which has largest portion of low energy, low emission sources, because more than half of our consumption comes from nuclear energy. Next, 11% is from hydro, which some of them are considered as renewable, but above 10 megawatts is not considered as renewable, but still is really low emission sources. Then we in our calculation, we need cover mainly these thermal conventional sources of electricity. And Slovakia has consumption roughly about 31 terawatt hour per year of electricity. We used official data from statistical office of the Slovak Republic, where they cover in chapter 4.1 agriculture, forestry and fisheries, their point of view for non-agricultural land, which there is called built area in square meters. And this data we collect in the table. There is only 10 districts shown. We have 79 districts in Slovakia, but we see that the highest portion of built up area is Bratislava, which is more than 58% of the land is covered with some concrete, asphalt, or some artificial structures. The lowest district is Brezno, which has only 2.13% of built-up area, but generally in Slovakia is almost 5% area with some artificial structure, which is 2.3 million square meter from 49 million of square meter. There is visualization of percentage of built-up area. You see that only our capital Bratislava and the second highest, biggest city in Slovakia has different colors, and all the data we combined in a methodology how to make calculation of possibility of producing PV electricity. There are some conditions which we use. They're described in this text and more detail in our article. We use 15 PV lifespan as minimum. We didn't calculate any degradation of PV system. And next, we use general panels with 333 watt power and with surface 1.65 times 1 meter. And because our variation of PV production is from 900 to 1,250. For this calculation, we used constant value as 100 kilowatt hour produced by 1 kilowatt of installed power. Then we made a calculation which is in this equation, and this result with constant that any square meter of inbuilt up area can produce 202 watt hour of PV energy. This we combine in calculation, and it results with what can be installed in any of district. As you see, even Bratislava is most covered by concrete, but still their production possibility is quite low because it's quite low, small district. But Prešov can produce about 10 gigawatt of installed power, which result in 10 terawatt hour annual production. In total, Slovakia could theoretically produce 482 terawatt hour per year from PV if all that land will be covered by PV, which of course is not possible in reality. There is a map of any district in Slovakia, how many these districts can produce. You can see that those south part of Slovakia, they have a nice sun covering and even a good portion of built-up area. This means all of them can produce above 13 terawatt hour of PV energy. I came to conclusion. Hypothetical production of built-up area is 482.3 terawatt hour, and some district can produce half of Slovakia electricity consumption. Of course, it's theoretical, but still is 15 times more than our consumption. It is hypothetical because it not consider places where we cannot install PV. There are no rowing and orientation considered, and grid connection is not considered with this theoretical approach. Of course, need to be improved, and there is continuing of our work. We are now trying to introduce map recognition. As you can see, map of Google can list all the buildings, which will give us much reliable number of production. We need to introduce more quality data source, which we will elaborate each district with their average solar production, and we need to combine with other methodology. Now we are working with calculation of EV consumption, charging possibilities when we will replace all our cars with electric cars, and we have more than 3 million cars in Slovakia, and sometimes in the future, I don't know, 5, 10, 15 years, all that internal combustion engines will be replaced with electrical, and all the cars need to be charged. Then now we are working how to combine this possibility of charging with PV production, because we see that charging of PV is quite difficult with our current sources. Thank you for attention. If you will have any question in future, you have my contact.
Okay, so thank you. So you avoid any discussion right now. No,
I say that
yes, in future, yes. Okay. So thank you for presentation. This study is very interesting, and I think there are a lot of issues which can be addressed and researched in the future for a successful implementation of this study. So maybe now we can open a discussion from the audience. Are there any questions? So if there are no questions, you can see a contact on my colleague, so you can directly write him an email with some questions, and I think he can provide the information related to this study and how to proceed for maybe other countries. Good.
Okay, thank you for the opportunity to present.
Thank you. So please stop the sharing of the screen. Okay. And now we are going to a third contribution. It is from the University of the Sofia, Bulgaria. The presenter here is Maria Alexandrova. And the topic of the paper is already shown on the screen. So Maria, it's your time. You can start your presentation.
Thank you very much, dear participants. My name is Maria Alexandrova, as you already understood. I'm coming from the Department of Microelectronics. This is Technical University of Sofia, Bulgaria. And I will try to present our work related to implementation of a system for utilization of thermal energy in compact solar energy harvester. This is the outline of my presentation, starting with a few introducing words about the motivation and the aim of the work, some details about the energy harvesting module fabrication, principle of operation and design of the electronics circuit for micropower processing, printed circuit board fabrication, components mounting, and system testing. Actually, our contribution is in the technology part, and I'm directly involved in the fabrication of the energy harvesting module. But I will do my best to give you sufficient detail about the electronic circuit as well to capture the idea of the entire module. So what's the primary idea here? The continuous irradiation of any solar cell causes rising the temperature in the films, and this results in decreasing the efficiency of energy conversion. So this is especially strong expressed if the modules are thin film and compact, small size. So in order to cool such a kind of system, you will need some kind of element like Peltier element, like thermoelectric generator, but it would be good if it is somehow integrated together with the solar converter. Well, if this thermoelectric generator work in the Peltier mode, it could take some energy from the heat, could convert this energy into temperature difference and cool back the solar module. If this is organized like a thin film, like a micro device, it could be split into a variety of segments. One of them could be responsible to absorb the heat and generate the voltage. It could be supporting additionally energy to the battery or storage capacitor. And the rest of the energy could be returned back as a second part of the module that could work at the opposite mode and use this energy to generate temperature difference. I mean to cool the overheated module and maintain constant temperature. Normally, such kind of system exists, but they use such kind of bulk thermoelectric converters, which normally requires great temperature difference across the PN junctions, and to achieve this, it is necessary to use heat sink at one of the sides, opposite sides to the across to the object being cooled, and this makes the system larger size, lack of compactness. So for practical applicability of a smaller system, we need to make it more compact. So regarding the power conditioning electrical circuit, it must be inserted somehow between the energy harvester and the electrical load that consumes this energy, because it is necessary to establish the signal to appropriate level, especially if it is fluctuating or lack of periodicity. So there are several approaches that have been discussed in the literature, but the most popular actually is the Dixon charge pump. It is some kind of amplifying DC-DC converter, boosting converter with a charging pump, and it was reported that if you have an input 1 voltage, you can convert it into, gain it into almost 16 volts. So it is very favorable for such kind of low voltage input that is expected to come from this system, because the temperature difference is actually less than 20 centigrades. A few words about the energy harvesting module fabrication. This is the solar converter part, and here this is the details about the thermoelectric converting part. So actually we use lead-free perovskite materials for absorbing layers in combination with cadmium telluride quantum dots. Both of them are responsible to cover the entire wavelength range of the spectrum, and some supplementary layers, titanium dioxide, gallium doped zinc oxide. They are serving as supporting the charge carrier transportation. Radio frequency vacuum deposition sputtering is used for the oxide coatings, and spin coating for the rest of the films. Regarding the thermoelectric converter, we used MEMS technology for three-dimensional high aspect ratio objects. It means thick film for photolithographic patterning and electroplating for growing the thermal legs into distinct thick films in shape at the thermal legs. So we use this approach because the diameter of each thermal leg is smaller than the height, and it is like a high aspect ratio object. They could be connecting an array according to a standard planar photolithographic process. So regarding the electronic circuit for micropower processing system, we used integrated circuit LTC 3107 linear technology manufacturer. The details that are given are that it consists of DC-DC boost converter, working with ultra low input voltage, controlling the power to extend the battery life. It could be also used in combination with some supercapacitor to store excess of the collected energy when it is available. And it could use the voltage at one of the pin related to the battery, this one, not only as a power source for the output when the input energy is absent, but also as a reference voltage to regulate the voltage of the output and to track the battery voltage like a feedback. So there are some external components that must be mounted to the integrated circuit. They have to be calculated properly. When there is no energy available for storage capacitor, this output capacitor should be sized to provide the necessary current when the load is switched on. And in the second case, we can have additional storing capacitor that could be charged up to 4.5 voltage. And there are some additional, how to say, consideration in the design related to the transformator. You can use specific ratio, turn ratio of the transformer. If it is 1 to 100, you can set the startup voltage or so-called startup to 20 millivolts, not microvolts, millivolts. It means that the whole system could work if the input is applied 20 millivolts. It happens when the temperature difference across the thermoelectric converter is less than 10 degrees Celsius. Here is the step-by-step PCB fabrication of the system. Actually, it is conventional flow of the technology, nothing special here. Maybe I have to mention the different etching solution for patterning the copper wires of the PCB. It is not ferric chloride, which is standard conventional etcher. Because it's strongly isotropic and strong undercut effect could appear and could completely remove from the PCB this critical spot, the place where the specialized integrated circuit is mounted. Actually, the distance between each pin is 12 micrometers, and the width of the contact path is 200 micrometers. So this undercut would completely remove these paths there. So we replace it with a non-isotropic etching solution from sodium persulfide. And the success in the system running depends on the precision of positioning of this microchip. It is hard to mount it because it is inverted flip chip package. At the back side of the package there is a cooling contact pad for heat dissipation, like a sink, like a layered sink, and we must keep to avoid short circuit by a side positioning. So we use special kind of die bonder and component placer with precision greater than 5 micrometers. This dispensing needle put solder paste on the contact pads. Here you can see a microscopic views, and this machine has the function to precisely set and program the thermal profile of soldering process to avoid boiling of the solder paste and void formation. So this will guarantee reliable electrical and mechanical bonding. And here the plots are just to demonstrate that even at temperature difference less than 10 centigrade Celsius, the cold startup voltage exceeds the threshold for the system, so fluently the charge could flow to the storage capacitor and the battery. This is just to demonstrate the capability for the working ability of this double solar plus thermal converter. As a conclusion, I can summarize that the proposed system is simple, compact, can meet the needs of low power consuming device, could be used as additional backup source of the solar energy harvester, could use part of this energy not for battery charging, but to charge the Peltier module to cool the solar elements, preventing efficiency drop due to overheating. And something that could be added, I'm realizing now that I didn't mention anything about the practical applicability, I mean where we need such kind of system. It is suitable to be implemented in informational displays on the bus stations, which are independently supplied from solar. That could give us information about the bus number when it's arrive and depart and so on, and for the street lights. Thank you very much for your attention.
Okay, thank you for your presentation and this practical approach, because I had one question, but you already answered it, so it was directly related to the practical implementation. But maybe I would also ask or propose to give some information related to the dimensions, because you have been speaking that the system is very small related to the microchip or the integrated circuits. So it would be nice to know what are the dimensions of the final system, and also some information related to the efficiency of the conversion.
Okay, about the size of the whole system, the module is in size 8 centimeter in width and 5 centimeter in the other dimension. It is mean the PCB. Directly on the PCB, it could be mounted the solar module, which is 2.5 centimeter to 2.5. It is square size. The conversion efficiency of the solar module in general is 25%. It cannot be expected more because it is thin film, not polycrystalline or monocrystalline silicon. It is lead-free perovskites, which are relatively new materials and still under investigation. So in general, this is
yes. So in general, the dimensions have been adapted to the solar system, or the
Yes, the dimensions are 8 per.
So this is a one cell, yes, or so
this is for the PCB together with the mounted solar module on the top of the PCB, and together with the integrated thermoelectric cooling module directly under the solar cell.
Okay. Some other questions from the audience?
I have one question also.
Okay.
Dear Professor Privalski, you asked about efficiency for PV module, but my question is about efficiency of thermoelectric module.
This was also my question. So the conversion efficiency from the thermal to electric.
Yeah, but
yes, it is approximately the same, but actually we need more investigation related to the long-term stability, because we have no such data to summarize about the efficiency. So it is not really trustable to see this momentum efficiency, but it is close to 20%.
20%. But colleague Alexandrova, you said that 25% is efficiency of PV module. And during your presentation, you said that the difference, the temperature difference between contacts of a thermoelectric module is just 10 kelvins, 10 degrees Celsius.
Could be. This is the minimum.
Just one moment, please. If you have such a difference between contacts of thermoelectric modules, its efficiency is lower than 1%. But I cannot say exactly how is high, but is lower than 1%. Is it possible to use thermoelectric generator as cooler for PV cells?
Yes, if it is integrated in the same system of fabrication of the thermoelectric module, because it is split into two parts. One half of this part is responsible to absorb the heat and convert into electricity. And the second part, fabricated by the same technology, use part of this energy to work in the reverse mode. If, of course, if you assemble with commercially available components, the situation will be not the same. Yes, it depends on the thermal capacity and the materials involved, but in this case, could be possible.
According to my opinion, it seems that you cool the PV cell just by mass of the thermoelectric module, not with the harvesting heat by it, because efficiency is too low for difference of 10 kelvins.
Well, it depends on the ambient temperature as well.
Take this remark for future research. This is a really serious lack of that, according to my opinion.
Okay. Okay, so maybe this is a good recommendation for the future.
Thank you very much for your opinion. We will think about this. Thank you very much.
Yes.
Welcome.
Okay, so thank for this contribution. And now we are going to a next contribution, which is from the Bilecik University. The presenter is Ahmet Emre Onay, and you can see already the topic of the contribution. So, dear Ahmet, I'm giving you a word, and you can start your presentation.
Thank you, Professor. And as you can see, my name is Ahmet Emre Onay. First, let me introduce myself. I'm a master's student in Bilecik University in Turkey, and together with my supervisors, Dr. Emrah Dokur and Professor Mehmet Kurban, we worked on performance comparison of new generation parameter estimation methods for variable distribution to compute wind energy density. So what we mainly focus on, I will first introduce you with the presentation outline. I'll start with the introduction, and I'll talk about the materials and methods we've used in our study. And then I'll talk about the results, and I'll end with the conclusion parts. And so, as you all know, the renewable resources are increasing, our use of them are increasing, and what we mainly focused on in our study is wind energy. And in order to install wind energy in some specific location, you first need to identify the wind speed characteristic of that specific site. So there are some certain tools used to do this job, and what we have mainly focused on in our study is the variable distribution, the two-parameter variable distribution. But there are many other tools like Burr, Rayleigh, and some neural networks, and these also can be helpful. So for this variable distribution, there are some certain parameter estimation methods, and in our study, we have compared these parameter estimation methods, and the data we have used is actually from the 32 cities in the 3 regions of Turkey. So as you can see here, all these, we have taken the wind speed data from all these cities, and we have used them to compare the parameter estimation methods. And the wind speed data is consisted of 3 years of hourly wind speed data, and it's 50 meters height. It's converted from 10 meters, and I'll talk more about this in the next slides. So as you can see, in some regions the wind speed is kind of low, and in the others, the two regions, the wind speed, wind energy density is higher. These two regions, Marmara and Aegean region, and the main reason is that they are closer to the coastal areas, and it's actually the places you can see the wind energy is utilized. So for the materials, we have used MATLAB software to compare to make a comparison between these parameter estimation methods, and we have taken the graphs and resolutions out of MATLAB software. And when we talk about the power law, as I mentioned before, the wind speed data was of 10 meters, and in the literature there are many tools to convert these data, and we have used power law to convert it from 10 meters to 50 meters, so it could be more workable. And the comparisons we made is consisted of 3 steps. The first one being the efficiencies of these parameter estimation methods in estimating wind speed probability. And the second comparison we made is the wind energy densities that were calculated by these methods. And the third one is we have compared the performance criteria of these parameter estimation methods, and these are root mean square error, wind energy error, and coefficient of determination. And some of them are used in statistics as well. So the reason we use two-parameter variable distribution is that, as you can see, the raw data is the graph, the first graph, and the two-parameter variable distribution takes this data and makes it in a more workable way. And by taking this graph, we can actually make a better comparison. So when we talk about the two-parameter variable distribution, I'll briefly just talk about this. It has 2 parameters, shape and scale parameter, and it's got 2 functions, probability density function and cumulative distribution function. These 2 functions involve the shape and scale parameters, and these parameters are estimated by these parameter estimation methods that I've talked about. And in our study, we have used 6 of these parameter estimation methods, and 3 of them are well-known parameter estimation methods, and 3 of them are actually newly proposed. So graphical method, maximum likelihood method, and justice moment method are mainly used in literature to make comparisons. And for example, wind energy intensification method has been proposed in the last year, in 2020. So we have taken all these methods, all these 6 methods, and compared them in 3 steps. And I'll also talk about these parameter estimation methods briefly. They mainly calculate the shape and scale parameter in their own way. And we take these shape and scale parameters and place them in variable distribution to make a better comparison. So in the second step, I talked about the comparison of wind energy density, and as you can see on the right, the actual wind energy density is calculated with this formula, and the variable wind energy density is calculated by the incorporation of shape and the scale values. And so we can compare the parameter estimation method's performance at calculating the wind energy density. So the third one is the performance evaluation, and these are the evaluation methods we have used: wind energy error, root mean square error, and coefficient of determination. So two of them are actually mainly used in statistics as well. So when we talk about the results, the graphs on the top show the probability distributions for each region. So the blue bar shows the actual wind speed data, and the line graphs show the estimations of these parameter estimation methods. And we want them to be as close to the actual values as possible. So when it exceeds a certain number of parameter estimation methods, they may overlap. So for this reason, we have actually taken, in the second graphs, you can see that the closeness of these values to the actual values. So we have highlighted the closest ones to the actual wind speed values. So the closest ones are the better performing ones. And for the Aegean region, the power density method is the better performing one among all the 6. For the Central Anatolia region, again, power density method is the better performing one overall. And for the Marmara region, power density method is the better performing one. And for the second step, we have compared these parameter estimation methods performance that's calculated to the actual wind energy density. And this is the actual wind energy density on the left for each region. And when we take a look at all these calculations, what we can see here is that the power density method is actually has actually made the spot on estimations for each region. So it is the better performing method for the 3 regions. And the closely following ones for each region, we can say that energy pattern factor methods and wind energy intensification methods. And for the third comparison we made, it's performance criteria, and for the performance criteria we've used for wind energy error, we are looking for the values closer to 0, and it's the same with the root mean square error. And for the coefficient of determination, we are looking for higher values, and it's more closer to 0, say closer to 1. So these are the results we have gotten from these performance criteria for each region. This is on our paper as well. You can check it out. We have highlighted the desirable values for each city. So for each table, I can say that it's for 3 regions. So for the resolutions, I can say that for wind energy error criteria, power density method is the better performing one. But for the root mean square error and for coefficient of determination, Justus moment method is the better performing one. And when we take an overall resolution of these all regions, we made a ranking here. Justus moment method for the values, for the desirable values, is the best method in the third comparison, and then follows maximum likelihood method and energy pattern factor method and power density method and so on. So overall lowest error values have been achieved by Justus moment method here. And when I talk about the conclusions, I can say that for the first comparison, probability distributions indicate that the power density method is the most accurate one. For the second comparison we made, it was about the wind energy density estimation. The power density method was the best performing methods among all. And for the last comparison, just this moment method has achieved lowest error values, but power density method has had acceptable error values as well. And overall resolution shows that the power density method is the better performing method among all. And thank you for listening, and thank you for your attention.
Dear Ahmed, thank you for your presentation. Now I am opening discussion. Are there any questions? So maybe just because of my interest, so these methods have been, let's say, well known. There is no method that you researched or delivered by yourself.
No, it's not a new method by me, but there have been a couple of new methods that has been proposed. Especially, I talked about the wind energy intensification methods, and this has been proposed recently. And energy pattern factor methods and power density methods they are kind of recent as well. But it's not there is a method proposed by me.
Yes, maybe in the near future.
In the future, yeah. I am hoping in my doctorate work I'm hoping to propose a new method.
Yeah.
Thank you.
Some other questions? Good. So thank you for your presentation once more. And now we continue to the last contribution. It is the paper from the Technical University of Ostrava, so our colleagues from the Czech Republic. And I would like to welcome Mrs. Teresa Paterova, who is a presenter of this contribution. You can see already the presentation and the title of the contribution. So dear Teresa, it's your time. You can start with the presentation.
Okay, thank you. Good afternoon. My name is Teresa Paterova, and I'm a research worker and also a PhD student at Technical University of Ostrava. And I would like to introduce you to the content of the paper that I wrote in collaboration with my supervisor, Michal Prauzek. The article is focused on predicting daily solar energy for the next day, and the prediction is based on pressure values. The approach used for forecasting was a deep learning approach in combination with multi-layer neural network. So predicting future solar irradiance is an important topic in the renewable energy field to improve the performance and stability of the system. For example, this parameter is used to improve the planning and operation of photovoltaic system. So the forecast could be used as a support parameter to control the operation duty cycle, data collection, or in communication activities at energy independent and also energy harvesting embedded devices. The solar availability can be predicting using many methods, such as statistical methods, some artificial neural networks, or support vector regression. We chose a deep neural network because it can add a complexity to a model without specifying what form the variation should take and allow the extraction of high-level features. So we were focused on the application of deep learning and neural network approaches, especially on deep feed-forward networks. There were used a back propagation method to train the network, in combination with deep learning methods such as optimization, gradient descent algorithms, batch normalization, and so on. I'm sorry. Now something about the experiment design. Here is on the figure shown the deep learning experiment algorithm for one configuration. For neural network training and testing were used two data sets, which was hourly measured pressure values are marked 2012, 2013. As you can see, first test configuration of deep learning method was set. That means there were chosen settings of optimization methods, gradient descent algorithms, etc. Then the neural network training was performed using the dataset 2012. And then the trained network was tested using the dataset 2013. Which results were the predictions of available solar energy for the following day. Then the evaluation parameters of the resulting dataset were calculated. These parameters were used for comparison to other test configurations of deep learning methods, which were performed. And this cycle was repeated for all experimentally selected combinations of settings, and then the results of each combination were compared to previous published approaches, and an overall evaluation was provided. Now, about the results. On this slide, you can see a table with the results of the best combinations of settings. For example, the results show that the N2 configuration has the lowest value of MAPE of all proposed settings combinations. It was also shown that the comparison of MAPE values of the N1 and N2 configurations, which had the same settings except for the number of layers. So it is better to choose a larger number of layers for a more accurate forecast. A1 and A2 configurations also had the same configuration apart from initialization method, and their comparison showed that the mode with sigmoid is better than with Xavier, for example. On this slide, you can see a table with 3 best experiment configurations and a graph of their prediction during the year against the target. The differences among these individual configurations are not statistically significant, as evidenced by the MAPE values. The graph shows that the neural network presents satisfying predictions in early spring, autumn, and winter, because there were no significant fluctuations in daily solar energy availability. In terms of summer months and late spring, the forecast did not correspond to sudden fluctuations, which are typical for these months. The comparison of the results to the reference approaches. The table on this slide shows the difference between the best result of our experiment, which has N2 label, and the reference approaches. The comparison of MAPE values shows that the best result was achieved using the support regression trees, the abbreviation is TR. It's here. SRT, I'm sorry, which exceeds our predictions obtained. However, the best forecast from our trained neural network surpassed all the above support vector regression models. The abbreviation is SV, so that's here and here. Or had comparable results with other approaches such as artificial neural networks A and N, general regression trees here, and others, as you can see, based on the MAP value. So the summary of used deep learning approach for solar energy forecasting is that it was satisfying predictions. There was satisfying predictions in early spring, autumn, and winter. But on the other times, it did not correspond to sudden fluctuations. Also, I'd like to mention that the time and computational complexity for neural network training was considerable, and therefore it was assumed the network was trained on an external computer or a cloud, where only the network parameters have been obtained and transferred to the embedded device. Using the parameters obtained in this way, it was simple to implement a prediction model of a neural network on an embedded system, because in the prediction phase, the network is represented by a lookup table. It is important to emphasize that the outcome of the learning process was greatly affected by the initialization of the parameters that used pseudo-random numbers generators. Therefore, different neural network training results could be achieved with the same settings. A possible improvement could be the use of more datasets measured over several years to train the neural network. And also another possible aspect could be using the dropout or L2 control method.
Okay, thank you.
So thank you so much for your attention. And if you have some questions, please let me know, or my colleague, Michael Pravosek.
Okay, unfortunately, chair should leave us a bit early before the session ends, and I will take care of you.
Okay.
Okay, and do we have any question from auditorium?
Just one from my side.
Okay, please, Dardan.
Thank you, dear Darius. For example, it is very clear what you did and what your research was. But for me, there is one unknown thing: harvestable solar energy from atmospheric pressure.
Mm-hmm.
Could you please give some details related to that? Is it possible in practice to collect energy from the sun, from the atmospheric pressure? How the name of the device or sensor somewhat?
It's not collected from the pressure. It's just based on the pressure. We know how much energy we are able to collect.
Mm-hmm. Okay, thank you.
You're welcome.
Okay, do we have any more questions? I have maybe two questions. How did you decide which method can be used in your research, and how did you choose which ones?
We choose deep neural networks, and it was random. It wasn't any any big reason to, because my supervisor Michal Prouzek already did this topic with different approaches, and now he chose the third one.
So maybe they were chosen not accidentally, but it is based on some parameters. Because if you are going to evaluate, let's say from the scratch, all methods, so why? Because you can go just over the references, analyze what other authors did, and do not waste time in this area. So maybe you can, let's say what kind of parameters you evaluated, and based on these parameters, you probably chosen some methods. So are there any parameters, any critical parameters in order to choose proper neural methods?
I don't know what to say.
Okay, I see. Okay, there is also in your paper that you analyzed some references, and there are a lot of methods which were analyzed in one reference. And so question would be like this one. Maybe it was not worth to analyze such amount of methods if somebody already analyzed and made some conclusions that maybe there are only 3 the best method, and the rest of them do not fit in your research scope. So how do you think, have you paid attention to that fact, or just
you're
took
right.
everything what exists and made analysis?
Yes, that's right. It's a good idea to do that in this way.
Okay. If we do not have any more questions, so we can end the session and today, the conference of today. And I hope to see you tomorrow at 9 o'clock in local hour time, European East time. Okay. So
Okay.
see you.
Thank you.
Bye.
Bye.
Bye.